Hello everybody, this is a one-shot for IIT Maths 2025. This takes care of all the important formulas that you need to know from all the chapters of Maths for IIT 2025. Now remember, one thing is very important, it is a one-shot. It's not a detailed video where we'll derive formulas or we'll go through the entire chapter, okay? So if you feel like you're getting stuck at any particular formula or you think that some concept is not clear, do make sure you go back and specifically read that part, okay? But from here, you'll understand that what are the different formulas you need to know, and I'll also be telling you what kind of questions can come from all these specific topics, alright? So the first chapter will start off with set theory. Now, okay, first thing you need to know is what exactly is a set. So a set is basically a well-defined collection of disjoint objects. So the thing you need to remember that you have disjoint objects in a set, which means you cannot have repeated elements inside a particular set, okay? Now, different types of sets. The first one is a singleton set. What is a singleton set? It's a set that only contains one element, right? What is a null set? A null set is a set that does not contain any element, right? So it's also known as the empty set and it's denoted by phi, alright? Finite sets, obviously, if the number of elements in a particular set is finite, then we'll call it a finite set, right? Infinite set is a set which contains an infinite number of elements, right? As the name suggests, okay? Universal set is the set that contains all possible elements of the sample space, right? Depending on what you're working with, your universal set will differ, right? Okay. Coming to subset, okay? So what exactly is a subset? If you take two sets A and B, and I tell you that every element of A is present inside B, right? Then we say that A is a subset of B, right? Similarly, we can also define what the idea of a superset is from here, right? So, in this scenario, A is known as the subset of B and B is going to be known as the superset of A, right? So, the bigger set is called the superset, the smaller set is known as the subset, right? Coming to what equal sets are, two sets are supposed to be equal if they contain the same number of elements and exactly the same elements, right? So, they need to be identical sets. Equivalent sets are sets which contain the same number of elements, even though the elements differ, as long as the number of elements are the same, we'll call them equivalent sets, okay? What is a power set? The collection of all possible subsets of a set is what a power set is, right? So if you take a set S, the power set is denoted by P of S, or you can use your own notation, and the size of this, okay? The number of elements inside the power set is given by 2 to the power n, if the size of S is n, okay? So if n contains n elements, power set is always going to contain 2 to the power n elements, okay? This is important, remember this formula, okay? Coming to the next thing, Venn diagrams. Venn diagrams are basically used to pictorially describe what our sets are, okay? So sometimes instead of writing it as a list, if we draw it as a picture and we talk about the operations, it becomes easier for us to understand what exactly is happening, okay? Now coming to operations on sets, okay? So if you have 2 or more sets, you can operate on them, and what kind of operations can you do? The first one is union. What exactly is union? It's a collection of all the elements which are present in either A or B, okay? So if I talk about 2 elements, A union B is the collection of all elements which is present either inside A or inside B, okay? So look at all the elements in A and B. If they're present either in A or B, just put them inside a set. That set is known as the union of these two sets, right? So union is always OR. Similarly, intersection is the elements which are present inside both the sets, okay? So whatever the common elements are, you'll get that if you take the intersection of these two sets, okay? So as you can see, union is OR, intersection is basically AND, right? Present inside A and B. Subtraction, okay? You can talk about the subtraction of two sets or the set difference, okay? So if you talk about set difference, A minus B, it's basically look at every element which is present inside B. If it's present inside A, remove it. Whatever is left out inside A gives you A minus B, okay? So elements in one set but not in the other, right? So all the elements inside A which are not present inside B is what you get when you take the set difference of these two sets. Cardinality of a set, the number of the elements present inside that set, okay? The size of the set is given by its cardinality and it's either given by n of s or mod of s, okay? Both of them denote the cardinality of the set. Complement of a set, okay? So if you have the universal set given to you, right? The complement of a set, if I take a set X, X complement is the universal set minus the set X, okay? So every element which is present inside the universal set but not inside X, okay? So basically you're removing the set X from the universal set. Whatever you are left out with is the complement of the set X, okay? Alright, so there are some operations you can do on sets. Next thing is some properties of these operations, starting off with commutativity, okay? So what is a union? As you can see, it's commutative, right? If you take A union B, it's always going to be the same as B union A. Same goes for intersection, right? A intersection B is always going to be equal to B intersection A, right? So these two operations are commutative. What is associativity? If you take A union B union C, that is the same as A union B union C, right? So the order in which you take the unions does not matter. That's the associativity of this operation. Same goes for intersection, right? So A intersection B intersection C is the same as A intersection B intersection C, alright? So both these operations are again associative. They're also distributive, right? You can distribute this union over this intersection, right? So you have A union B whole intersection C is nothing but A intersection C union B intersection C, right? Same for intersection A intersection B union C is nothing but A union C intersection B union C, right? So you're basically distributing these two over this operation union, right? Okay. Now some important results on the cardinality of sets, right? Again, this is a very important thing. There are a lot of questions that come from here and you've seen these questions a lot. So the size of A union B is always the size of A plus the size of B minus the size of A intersection B. We'll do this when we come to Venn diagrams in the next slide. But for the time being, just remember this. Similarly, the size of A union B union C can be written as the sizes of the individual sets minus the intersection taken 2 at a time plus the intersection taken 3 at a time, right? This is also known as the principle of inclusion and exclusion, right? Okay. De Morgan's law basically deals with complements, right? So if you take the A union B and you take its complement, you'll end up with A complement intersection B complement, right? So in some sense, the complementary event of union is intersection, right? Same goes for intersection. If you take the complement of intersection, you'll get A complement union B complement, right? So this is what De Morgan's law works with. Coming to inclusion and exclusion, it's basically a principle of calculating the cardinality of union and intersection of sets, right? So like we said, if you look at these, okay, so this is what a Venn diagram looks like, right? So if you take two sets A and B, this part which is common to both these sets is nothing but the intersection, right? This A intersection B. What is union? Everything inside these two circles is known as the union, right? Again, if you look at this red part, it's nothing but A minus B, right? Because you're taking every element inside B and removing it from A, right? Same, this way you can define what B minus A is. Now, if you look at the size of this entire thing, if I talk about the size of A union B, that is going to be first add the size of A to it, add the size of B, right? But when you do this, you can see that this intersection gets added twice, once for A and once for B, right? So you need to subtract it to get rid of the overcounting, right? So you subtract A intersection B from it, okay? So this is what the principle of inclusion and exclusion tells you. And you can do the same thing for the union of three sets, right? You add A, B, C, so these parts are common, so you subtract it, right? But when you're subtracting it 3 times, this gets over subtracted, so you need to add it in the end, right? That is the idea of principle of inclusion and exclusion. Cool. Coming to the next chapter, which is relations, again a very important chapter. Lots of questions come from here and it's very easy, okay? So if you're a bio student, you should pay attention to this chapter. What exactly is a relation? So relation is nothing but a set of ordered pairs representing the relation between two particular sets, okay? For example, if I talk about this relation A comma B, where A and B are integers and A is less than B. So this relation is less than, right? We're taking all pairs, and once we take a pair, we know for sure if it's present inside this relation, the first element has to be smaller than the second element, right? But if we formally want to define it, we need to define what Cartesian product is, okay? So Cartesian product again is another operation on a set. So what is A cross B? It's basically all ordered pairs A comma B, where A lies in the first set, B lies in the second set, okay? So you take element from the first set, you take element from the second set, you write it as an ordered pair, and the collection of all these ordered pairs gives you the Cartesian product of these two sets, okay? Now, any relation you take is nothing but a subset of the Cartesian product, okay? So any relation is a subset of A cross B. This is what the formal definition of a relation is. Now, different types of relation. The first one is identity relation. Identity relation is you basically take every element, okay? You take every element and you want that element comma that element to be present, okay? So again, identity relation is only defined on an individual set, okay? If you are defining a relation on one set A, only then you can talk about identity relation, okay? So what is identity relation? This set should only contain elements of the form A comma A for every A present inside A, okay? This is identity. And if you know reflexive, it's slightly different from reflexive and we'll come to that in a second. But this is clear. For example, if I take A to be 1 comma 2, then the identity relation only contains 1 comma 1 and 2 comma 2, right? Okay. Now, the different types of relations, again, a very important part of this chapter. The first type is a reflexive relation, right? So what exactly is a reflexive relation? So it's a relation where if you look at any element of A, you want A comma A to be present inside R. That's it. Look for every element of A if the pair A comma A is present inside that relation, we'll call it a reflexive relation. Now, how is this different from the identity relation we just looked at? Because in this case, apart from these pairs, you can also have other pairs present inside that relation, okay? But for an identity relation, these are the only elements that can be present inside that set, right? Okay, for example, this one, see, these three elements are present, but apart from it, you also have two other elements present inside this, right? So that's why this is reflexive, but it's not an identity relation, okay? The second kind is symmetric relation. What is it? If you have the pair A comma B inside this relation, you also want the pair B comma A to be present inside this relation, right? That's it. Look for every pair A comma B. If B comma A is also present, then we'll say that it's a symmetric relation, right? Transitive, again it follows the transitive nature. So if you have a pair A comma B and you have a pair B comma C, then from here you want this pair A comma C to be present inside R. Okay, so if it's true for every two such pairs, then we'll say that the relation is transitive. Okay, for example, if I look at 1, 2 and 2, 3, see AB, BC is present, so you want 1 comma 3 to be present and it is present, right? Okay, so this relation is a transitive relation, right? Now, any relation which satisfies all three of them, if it's symmetric, if it's reflexive and if it's transitive, then we call those relations to be an equivalence relation, right? So it's basically the best form of a relation we can get. Okay, all right. Now, counting the different types of relations that you can form on a given set. So, for a reflexive relation, if you have a set A, okay, so in all these cases, we'll consider a set of size n, okay. So, number of reflexive relations on a set with n elements is given by 2 to the power n square minus n. Remember this. Number of symmetric relations is given by 2 to the power n square plus n by 2, okay. Transitive relation, there is no general form of finding it, so you'll have to manually count it, okay. For example, for n equal to 1, you only get 1 transitive, for 2 you'll get 3, for 3 you get 19, okay. So it doesn't really follow any specific nature, okay, but these two are important, okay. So remember the number of reflexive relations that you can form, the number of symmetric relations you can form, alright. Coming to the next chapter, which is basic maths, okay. Again, simple chapter for all the bio students, especially if you want to attempt maths, these are all simple chapters for you. So first thing we talk about is inequalities, okay. So some standard properties of inequalities. First one is if A is less than B, then A plus C is always going to be less than B plus C, right? So you can add any real number on both the sides of a given inequality, okay. So in this case, we are adding C to both the sides. Second one is if you have A less than B and you have a positive real number, okay, then you can multiply both sides and the inequality does not change, okay. So in this case, if you multiply by a positive number, AC will still be less than BC, alright. The third property is if you multiply with a negative number, then what happens? If you multiply both sides with a negative number, then the inequality basically reverses, right? So if A was less than B and you're multiplying by some negative C, then now AC is going to become greater than BC, right? So the sign changes. Again, similarly, if you have two positive numbers, you can take the reciprocals of the inequality given to you, right? So if A, B are positive, then 1 by A. I mean, if A is greater than B, then you can cross multiply and you'll get that 1 by A actually is less than 1 by C, okay? Cool. Coming to some important inequalities. The first one obviously is the arithmetic geometric mean inequality. So what is the AM? So if I want to generalize this, AM basically is always the sum of the real numbers. So because you have n real numbers. One thing you need to remember, this is only true for positive reals, okay? You need your numbers to be positive reals, only then you can use AMGM. So the sum of these numbers divided by the total number of numbers, essentially the average of these numbers, is always going to be greater than equal to the product of these numbers to the power 1 by n, okay. So this is a special case when n is equal to 2. So the left hand side becomes a plus b by 2 greater than equal to ab to the power 1 by 2, right? But you can also generalize it for n variables, okay. Second one is the Cauchy-Schwarz inequality, which tells you that a1 square plus a2 square times b1 square plus b2 square is greater than equal to a1 b1 plus a2 b2 whole square, okay. You can also generalize this. Basically, you have two sequences of numbers, okay, say a1 till an and b1 till bn, alright. So what you do is, you take the sum of the squares of the elements of each of these sequences, right? So summation ai squared, right, times summation bi squared. This is always going to be greater than equal to, you take the pairwise product, right? So a1, b1, a2, b2. So essentially you take pairwise product, you look at the sum of this, the sum whole squared, okay? So summation ai squared times summation bi squared is greater than equal to summation ai bi whole squared. This is the generalized Cauchy-Schwarz and this works for all real numbers, okay? Here your numbers don't have to be positive reals. Okay, this works for all real numbers, okay? Third one is, what is a triangle inequality involving modulus? So mod of a plus b is always less than equal to mod a plus mod b, right? This is a simple triangle inequality, okay? Coming to now some special functions, the first one we'll talk about is obviously logarithm. So how is log defined? So we say that log of a base b is equal to x if and only if b to the power x is equal to a. Okay, that is the definition. Cool. Now some laws of logarithm. Log of the product, if you split it, it turns out to be log m plus log n. So okay, so we keep the base the same, so it's base b. So log of mn base b is nothing but log m base b plus log n base b, right? Similarly, if I look at the ratio now, so log base b m by n is nothing but log m minus log n, right? If you have power inside will just turn out to be r log m, right? So this is a special case of this, right? Here all your numbers are the same essentially, right? So if you have log m to the power r, it just turns out to be r log m, okay? Changing the base, so if you have log a base b, you can write it as log a base any base k that you are choosing divided by log b base any base that you want k, okay? Just remember that these two new bases have to be the same, okay? So this is the idea of base conversion. Standard values, log b base b is always 1, log 1 base b is always equal to 0, right? Okay, and what does a graph of log look like? So if your base is something greater than 1, your logarithmic graph looks something like this, right? So log x base b where b is greater than 1. Right? This is what your graph looks like, and this point is nothing but 1, 0, right? Cool. So it's a strictly increasing function, right? Okay. Next thing we talk about is the modulus function. So what is the definition? So mod function is basically the absolute value, right? So whatever you have, just ignore the sign. Whatever the absolute value of that number is what you'll get after you take the mod, right? So mod x is defined as x if x is greater than or equal to 0, and it's just going to be minus x if x is less than 0, right? For example, if x is equal to minus 5, mod x is minus of x, which is nothing but 5, right? Okay, and if x is 5, then mod x is just equal to 5. Now some properties, mod x is always greater than or equal to 0, mod of x is equal to mod of minus x, yep. Mod of the product of two numbers is equal to mod of x times mod of y. Mod of the ratio, if you take mod of x by y, it's going to be mod x by mod y given y is non-zero, otherwise the ratio is not defined. Triangle inequality, we just saw it, it's mod of x plus y is less than or equal to mod x plus mod y. A slightly complicated version, that x minus y is going to be greater than or equal to mod of mod x minus mod y, okay? Okay, that's just building up on the triangle inequality. And what does a graph of mod x look like? It basically looks like this, right? It's actually positive, it's symmetric about the y-axis. This point obviously is 0, 0, right? So this is what the graph of mod x looks like. Okay. Next, another important function for us, the greatest integer function. So how is the greatest integer function defined? Box x is basically the greatest integer less than or equal to x, right? That is, you look at the real line, find x. See, if x is an integer, this itself is its box value, right? But if not, look for the greatest integer that is less than or equal to x, right? Find the nearest integer less than or equal to x. This is what box of x is going to be, okay? Some properties, x always lies in between box x and box x plus 1. You can also say that box x always is greater than or equal to x and it's less than x plus 1 always, right? Second one is box of minus x is minus of ceiling of x, right? This is different. This is the ceiling function or the least integer greater than or equal to x, right? So if this is box x, if it's not an integer, find the least integer greater than or equal to x, right? So this gives you ceiling of x, okay? So box of minus x is minus of ceiling of x. If x is an integer, then obviously box x is going to be equal to x, right? So some standard properties of the greatest integer function. Next thing is the fractional part. It's another function that we define based on this box function, okay? So fractional part of x is nothing but x minus box x, okay? Whatever number you have, subtract the box part from it, that gives you the fractional part, okay? So you can see fractional part is always going to be greater than or equal to 0, but it's strictly less than 1, right? And for every integer, it's going to be 0. Otherwise, it's always in between 0 and 1, right? If x is an integer, then fractional part of x is 0. Fractional part of x plus n is equal to fractional part of x, okay? So adding any integer to it, if I add an integer to some number, the fractional part doesn't really change. It remains the same, okay? So there are some simple standard functions that we need. Coming to the next chapter, which is trigonometry, okay? Again, one of those chapters, it's very simple. All you need to do here is memorize a lot of formulas. That's it, okay? So let's look at what are the formulas that are important to you. First of all, how do we define the basic trigonometric ratios? So sine theta, if you have a right angle triangle, okay? If you have a right angle triangle, look at this angle theta, okay? So corresponding to this, we can define these 6 trigonometric ratios, right? What is sine? It's basically perpendicular by hypotenuse, right? So the side opposite theta is always considered the perpendicular. The side, the arm involving theta is always known as the base, okay? So sine theta is perpendicular by hypotenuse. Cos theta is base by hypotenuse. Tan theta is perpendicular by base. Now cosec is basically inverse of sine, right? Similarly, sec is inverse of cos and cot is inverse of tan, right? So once you define the 3 in the main three ratios, you can define the other three based on that, right? So you can see cosec basically becomes the inverse of this. So hypotenuse by perpendicular, this becomes hypotenuse by base, and the last one becomes base by perpendicular, right? Okay, these are some standard trigonometric ratios. Some basic identities, like I said, sine and cosec, they're inverses of each other, so they'll multiply to give you 1. Cos and sec are inverses, so they'll give you 1. Tan theta and cot theta multiplied together will give you 1, right? Now tan theta is again sine theta by cos theta, and cot theta is nothing but cos theta by sine theta, right? Okay. Now sine square theta plus cos square theta equal to 1, we know this, okay, we have been doing this since we were kids. Sine square theta is 1 minus cos square theta, you can write it from here, or you can write that cos square theta is 1 minus sine square theta. Similarly, for sec and tan, you can say that sec square theta minus tan square theta is equal to 1, or you can write that sec square theta is 1 plus tan square theta, okay? Or similarly the other way, tan square theta is equal to sec square theta minus 1, right? Remember, it's important to know this basic identities because you'll be using this a lot, especially when it comes to integrals of trigonometric functions, okay? Or even while calculating limits, you need these identities. Similarly, sec theta plus tan theta can be written as 1 by sec theta minus tan theta. Why? Because this is equal to 1, right? Basically, you can factorize this as a plus b times a minus b. Now the next one, sec square theta minus cot square theta is equal to 1, again exactly the same as this, and you have the other two variants, and similarly just like g you can define this, okay? You can say that cosec theta plus cot theta is 1 by cosec theta minus cos theta, okay? Cool. Some standard values, some standard angles and some standard values, okay? So if I look at sin theta, okay? Sin theta, sin 0 is 0, sin 30 is half, sin 45 is 1 by root 2, sin 60 is root 3 by 2, sin 90 is equal to 1, right? Cos, basically you write this in the reverse order, so 1 root 3 by 2, 1 by root 2, half and 0. For tan, tan 0 is 0, tan 1 is, again you can just take the ratios of these two, right? So tan 30 is going to be 1 by root 3, tan 45 is going to be equal to 1, tan 60 is root 3, tan 90 is not defined, right? Okay, because cos 90 becomes 0. Similarly, cot 0 is undefined because sin base is equal to 0, otherwise it's the inverse of this, right? Similarly, you can define sec theta and cosec theta, right? So these are some standard values for some standard trigonometric angles, okay? So now let's look at the sum and the difference formulas. The sine of a plus minus b is sine a cos b plus or minus cos a sine b, depending on whether you're taking plus or minus. Similarly, cos of a plus minus b is cos a cos b minus plus sine a sine b, okay? So if you take plus here, you'll take minus here. If you take minus here, you'll take plus here. Tan of a plus minus b is tan a plus minus b divided by 1 minus plus tan a tan b, right? So using this, you can find out the trigonometric values of different angles, okay? Provided there's some or differences of standard angles, okay? Next thing is formula to transform the product into a sum or difference. So 2 sin a sin b is nothing but sin a plus b plus sin a minus b, right? Okay. Second one is 2 cos a sin b is nothing but sin a plus b minus sin a minus b, right? 2 cos a cos b is cos a plus b plus cos a minus b. 2 sin a sin b is cos a minus b minus cos a plus b. Similarly, sin c plus sin d is 2 sin half sum times cos half difference, right? Similarly, sin c minus sin d is 2 cos half sum sin half difference, right? Cos plus cos is 2 cos half sum cos half difference. Cos minus cos is minus of 2 sin half sum sin half difference, okay? Cool. Now sin a plus b plus c, suppose you have three angles, how do you do it? Just treat these two as the first angle, right? Then you can use the formula for sin a plus b, right? So it turns out to be sin a plus b cos c plus cos a plus b sin c, okay? And if you want to simplify, it simplifies to sin a cos b plus cos a sin b times cos c blah blah blah, okay? So you can, you can expand this from here, okay? Even if you don't remember, as long as you remember the formula of sin a plus b, you can expand it, okay? Same goes for cos a plus b plus c, right? Write it as cos a plus b as the first angle, right? So cos a cos c minus sin a plus b sin c, okay? And then you can expand it to get this entire formula, okay? Same goes for tan, right? Again, tan you can write it as treating a plus b as the first angle, and then if you want, you can further expand it. Cool. Alright. Alright, so the next thing we talk about is trigonometric ratios of multiple angles, okay? So double angle essentially. So if you have something like 2 theta, then we can write sin 2 theta as 2 sin theta cos theta, or it can also be written as 2 tan theta divided by 1 plus tan square theta, okay? Secondly, for cos 2 theta turns out to be cos square theta minus sin square theta, which can also be written as 2 cos square theta minus 1, or 1 minus sin square theta, or 1 minus tan square theta divided by 1 plus tan square theta, okay? 1 plus cos 2 theta, from here you can get that it's 2 cos square theta. Similarly, 1 minus cos 2 theta is nothing but 2 sin square theta, okay? Tan theta is 1 minus cos 2 theta divided by sin 2 theta, or sin 2 theta divided by 1 plus cos 2 theta, right? And what is the value of tan 2 theta? It's 2 tan theta divided by 1 minus tan square theta, right? So you can get all these formulas by basically putting a equal to b equal to theta in the sum formula that we saw, okay, for trigonometric functions, okay? Next is trigonometric ratios of some multiple angles, right? So you can write sin theta as 2 sin theta by 2 cos theta by 2, or it can be written as 2 tan theta by 2 divided by 1 plus tan square theta by 2, right? Similarly, you get cos theta as cos square theta by 2 minus sin square theta by 2, which is nothing but 2 cos square theta by 2 minus 1, or 1 minus 2 sin square theta by 2, right? Which can further be written as 1 minus tan square theta by 2 divided by 1 plus tan square theta by 2, right? This is just replacing theta with theta by 2 in this equations, right? If you put theta by 2, you'll get theta by 2 here and you'll get theta on the left hand side, right? Okay. Third one is 1 plus cos theta is nothing but 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2, right? Similarly, tan theta by 2 is nothing but sin theta by 1 plus cos theta, or 1 minus cos theta by sin theta, right? These formulas are important because you'll be using these a lot for trigonometric integrals and limits, okay? Similarly, you can write tan theta as 2 tan theta by 2 by 1 minus tan square theta by 2. Sin theta by 2 again is plus or minus root over 1 minus cos theta by 2, right? Cos theta would be plus or minus 1 plus cos theta divided by 2, right? Tan theta by 2 is plus or minus square root of 1 minus cos theta by 1 plus cos theta. And same for the rest of these formulas, okay? So even if you can't remember it, just remember where these formulas come from, right? Because as you can see, there are like 12 different formulas here, right? So as long as you remember a couple of them, you can always derive the rest of them from those formulas, okay? Right. So some special formulas, some special forms, which helps in a couple of cases. You can use these as shortcuts. So sin theta times sin 60 minus theta times 60 plus theta is always going to be 1 by 4 sin 3 theta, okay? Similarly, cos theta times cos 60 minus theta times 60 plus theta is 1 by 4 cos 3 theta. For tan theta, tan 60 minus theta, tan 60 plus theta is nothing but tan 3 theta, which is nothing but the ratio of these two equations, right? Okay. Summation of trigonometric series, okay? So if you have your arguments, okay, or the angles in an AP, for example, you have sin alpha plus beta plus sin alpha plus 2 beta, so on and so forth, all the way till alpha plus n minus 1 times beta. Then this sum can be written as sin n beta by 2, sin of alpha plus n minus 1 beta by 2 divided by sin beta by 2, okay? Or if you want to simply remember it, it's nothing but sin of first angle plus last angle by 2 times sin n beta by 2, beta is a common ratio, divided by sin beta by 2, okay? Similarly, you can find an equation for cos, okay? Right. Now coming to trigonometric equations, okay, the next part of trigonometry. So if you have sin x is equal to k, then the general solution of this equation is always n pi plus minus 1 to the power n sin inverse k, okay, where this is the principal solution of it, right? Similarly, cos x equal to k implies x is going to be 2n pi plus or minus cos inverse of k, right? Tan x equal to k means x is going to be n pi plus tan inverse of k, right? So in general, if you're asked to find general solutions, this is what you'll use, okay? Now, special cases of some trigonometric equations, if sin x is equal to 0, then x is nothing but a integer multiple of pi. Similarly, if cos x is 0, then x is an odd multiple of pi by 2, okay? So 2n plus 1 times pi by 2, where n is an integer. Similarly, if tan x is equal to 0, then x is an integer multiple of pi. Sin x equal to plus or minus 1 implies that x is pi by 2 plus 2n pi, okay? Similarly, cos x equal to plus or minus 1 implies that x is nothing but an even multiple of pi, okay? Cool. Now some range of trigonometric functions. So if you look at sin x, we know sin x can only take values in the interval minus 1 to 1, both included. Same goes for cos. Tan x can take any real value, okay? So the range of tan x is minus infinity to plus infinity. Same for cot x. Sec x can take all values in real lines except the interval minus 1 to 1, which can be written as minus infinity to minus 1 included, union, close 1 till infinity, right? Same goes for cosec. Cosec can take values from minus infinity to minus 1 closed, union 1 till infinity, okay? Cool. Now, periodicity of functions, okay? Periodicity of trigonometric functions. Again, a quick recap. What is a periodic function? If you can find some t such that f of x plus t is equal to fx for all x, then we say that t is the period, okay? The smallest t for which this holds is called the period of this function. So, sin and cos have period 2 pi, tan and cot have period pi. Similarly, sec and cosec have period 2 pi, right? So, you need to remember this. Now, some mistakes that you should avoid when you're doing questions of trigonometry. Do not get confused in the signs, okay? It's confusing because sin is, if you, like we saw, sin of a plus minus b is sin a cos b plus or minus cos a sin b. But for cos, it reverses, right? So remember the sign conventions where you're using plus, where you're using minus, okay? Do not directly use Pythagorean identities, okay? If you're taking the square root, be careful to look at the value, okay? Because sometimes you get extraneous solutions, sometimes the solutions are not valid, okay? So make sure you take care of that, okay? Do not forget the general solution, okay? Whether it's a multiple of pi, whether it's a multiple of 2 pi, so on and so forth. Do not forget these things, otherwise you'll end up with some wrong solutions, okay? Interpreting angles in different quadrants. This again is similar to finding the sign, okay? Sign is positive in which quadrant. Do not forget all these things, okay? Simplify it properly. Do not overlook the possibility of multiple solutions in triangle problems, okay? there might not be a unique solution. There could be multiple solutions. Okay, so make sure you keep all these things in mind, okay, whenever you're doing questions of trigonometry. Right, so that takes care of trigonometry for us. Coming to the next chapter, which is sequence and series. Again, one of the simpler chapters. There are only a few formulas that you need to remember from here. So first one is, the first progression we'll talk about is what an arithmetic progression is. So what exactly is an arithmetic progression? So if you have a sequence of numbers or a random bunch of numbers where the difference of any two consecutive numbers is constant, then that particular progression is known as an AP, right? And the constant difference that you get is known as a common difference. So an AP basically will look like A plus D, A plus 2D, and so on and so forth, right? That is the idea of what an AP is. Cool. So if A is the first term and D is a common difference, the constant difference of consecutive terms, right? Then the nth term of an AP can be defined as Tn, which is A plus n minus 1D, right? And the sum of the first n terms of an AP is nothing but n by 2 plus 2A plus n minus 1D, right? You can either go with this form or you can use the form, it's n by 2 A plus L, where A is the first term and L is the last term, right? Also, if you have a scenario where the sum of the first R numbers is given, right? So you can write that TR is nothing but the sum of the first R numbers minus the sum of R minus 1 numbers, right? Which is kind of obvious, right? Because what is SR? SR is basically T1 all the way till the R term, right? Similarly, SR minus 1 is T1 all the way till TR minus 1. So if I write this as TR minus 1 plus TR. So when you take the difference, this entire block cancels out and you're left out with TR, right? So you can also use this for a few questions. Right, some properties of an AP. So if ABC are in an AP, then I can say that twice the second sum is always equal to A plus C, right? And if ABCD are in an AP, then the first and the last term, their sum is equal to the sum of the middle terms, right? So A plus D is equal to B plus C. If you have three numbers in an AP, you get a lot of questions where it's given that three terms from an AP or three roots of a polynomial from an AP and so on and so forth. So in those cases, if you have three numbers, always take them to be A minus D, A and A plus D, right? If you have four numbers, then take them to be A minus 3D, A minus D, A plus D and A plus 3D, right? Same goes for 5 terms or 6 terms and so on and so forth, right? Essentially, the idea over here is if you have to take the sum of these numbers, we want to get rid of this one of the variables, right? You have two variables here, A and D, right? So if I take the sum of this, you can see that D cancels out, right? So if you have some constant given to you where the sum of these terms in the AP is given, then just taking the numbers in this form eliminates one of the variables directly and you can find out the value of A, right? Okay. The third property is sum of the terms of an AP equidistant from the beginning and the end is equal to sum of the first and last term, right? Basically, second from the beginning and second from the last, their sum is going to be the same as the difference of the terms at the extremes, right? Same goes for, say, third from the beginning and third from the last and so on and so forth, right? So that is what this equidistant from the beginning and end means. Okay. Next thing we'll talk about is arithmetic mean, right? So we saw that if you have three terms in an AP, then the middle term is called the average of it, right? Because we saw that 2B is equal to A plus C, right? So we know that B is nothing but the average of the other two terms, right? Now if you extend this idea to inserting n arithmetic means between two numbers, then that basically means you have the first number, the first arithmetic mean, the second arithmetic mean, all the way till the nth one, comma B. This entire thing forms an AP, okay? That is what it means. Now if you want to find the general term of this, observe that this has how many terms? N plus 2 terms, right? So B is going to be A plus n plus 2 minus 1, so n plus 1D, right? So the common difference of this AP is nothing but B minus A by n plus 1. So the first arithmetic mean is what? It's nothing but A plus the common difference. Second term is A plus twice the common difference all the way till the nth term, right? The nth arithmetic mean is going to be, which is the n plus 1th term of the AP, that's going to be A plus n times B minus A by n plus 1, right? Okay, and if you add all these arithmetic means, you always end up with n times capital A, okay? Where capital A is the single AM between A and B, that is capital A is nothing but B plus A by 2, okay? Cool, so this is the property of means. Now coming to the next progression, which is the geometric progression. So AR square all the way till so on and so forth is called a GP, where A is the first term and R is a common ratio. Essentially, if you have a progression just like AP, now if the ratio of consecutive terms is constant, okay, ratio of any two consecutive terms is constant, then it's known as a GP, and this constant ratio that you get is known as the common ratio, okay. So using that, you can say that a GP would look something like this, okay, AR square, so on and so forth, right. So the nth term of this GP is nothing but A times R to the power n minus 1. The sum of the first n terms is given by Sn is equal to A times R to the power n minus 1 divided by R minus 1, given that R is not equal to 1, right? Because if R is equal to 1, you basically get a constant GP. In that case, the sum basically turns out to be n times A, okay? Sum of an infinite GP, right? So in case of a GP, we can talk about an infinite GP, then its sum is nothing but A by 1 minus R, given that mod of R is less than 1, right? So the absolute value of the common ratio should be less than 1, only then the sum of an infinite GP is defined, right? Okay. Coming to geometric means, right? Just like AMC, you can also insert geometric means between numbers. So in this case, what it would mean is you have A, G1, G2, all the way till Gn, comma B, right? So now these terms are going to form a geometric progression, okay? So if you look at B, B is the, what is this? Again, n plus 2th term. So B is nothing but A times r to the power n plus 1, right? N plus 2 minus 1, so r n plus 1, right? So the common ratio is nothing but B by A whole to the power 1 by n plus 1. So using this, you can find the values of all the geometric means. So its first term is going to be, first geometric mean is going to be A times B by A to the power 1 by n plus 1. Second time it's going to be r square, right? Third one is going to be A times r cube all the way till n, which is going to be A times r to the power n, right? So you can find the closed form of all the geometric means that you are inserting between these numbers, okay? Fine. Harmonic mean. What is a harmonic mean? So A, B, C are said to be a harmonic progression if their reciprocals form an AP, right? So similarly, you can also define what harmonic means are, okay? So the harmonic mean of these n numbers is given by 1 by h is 1 by n times the sum of the reciprocals, right? Okay? Right. So relation between the means. So for two numbers, you can say that the geometric mean squared is equal to the arithmetic means times the harmonic means. But remember, it's only for two numbers, okay? And in general, we always have AM greater than equal to GM greater than equal to HM. And equality only holds if all these numbers are equal, okay? If all the numbers are equal, you'll get the equality case, alright? Cool. Now, some important results about sum of series, you need to remember that if you have two individual terms, right? If you have summation of AR plus or minus BR, you can split this into two different sums, okay? Similarly, summation of K times AR, you can take this constant K outside and it just turns out to be K times summation of AR, okay? Summation of a constant, okay, if you look at this, you are adding a constant how many times from R equal to 1 to n, so it's going to be nothing but n times the constant. Summation of R, summation of the first n natural numbers is n times n plus 1 by 2, sum of the first n squares is n times n plus 1 times 2n plus 1 by 6, cubes is n square times n plus 1 whole square divided by 4, and if you have some summation that looks like twice summation of AI, AJ, that is nothing but this entire square minus sum of the squares individual, okay? So remember these some important results, okay? Right. Now let's come to the next thing, which is known as a method of difference, okay? This is again not really super important for you guys, but it's good to know in case you want to derive it. I would actually recommend you to just derive it, right? Suppose you have some terms in some progression, okay? Right? And it's given that the difference between U1, the difference between the first two terms is U1, the difference between first two terms is U2 and so on and so forth, right? Now, if all these are constant, then you basically get a arithmetic progression, right? But there is a chance that these are not constant, right? So what might happen is the difference of these differences is constant, right? So this is known as a layer 2 AP, okay? Similarly, if the difference of the difference is constant, basically W1, if this is constant, then it's known as a layer 3 AP, okay? And you can go on and you can derive your entire progression using this, okay? So you don't need to remember the characteristic equation, but just remember there are some sums that might ask you to find sum of some terms in a progression where the difference is actually an AP, okay, instead of the terms themselves, okay? So you can backtrack and find the actual terms, alright? Cool. Alright, so the next chapter we'll do is Binomial Theorem, okay? Again, a very simple chapter, only one formula like defines this entire chapter. So what exactly is a Binomial Theorem? It's basically expanding binomial terms to some random power, right? So if you want to expand x plus 5 whole to the power n, you end up with something that looks like r equal to 0 to n choose r, x to the power n minus r times 5 to the power r, where NCR is defined as n factorial by r factorial times n minus r factorial, right? The general term of this expansion, so if you observe r starts from 0, right? If you put r equal to 0, you get the first term. So essentially the rth term is given by tr plus 1, which is NCR. Sorry, the r plus 1th term would be when you substitute the value of r, right? So 0 gives you 1, so 1 will give you 2 and so on and so forth. So the r plus 1th term of this expansion is given by NCR, x to the power n minus r times y to the power r, right? Alright. Now if you talk about the number of terms, you can see clearly you get n plus 1 terms, right? If you raise this to the power n, you get n plus 1 terms in total, right? Starting from n choose 0 all the way till n choose n, right? So you get n plus 1 terms, okay? Alright, cool. Now the middle term of this expansion is given by t of n by 2 plus 1 if n is even, and if n is odd, you get two terms which look exactly the same, right? And that is n plus 1 by 2th term and the n plus 3 by 2th term, okay? Now these terms, so this NCR is known as the binomial coefficient, right? So some of the properties of these binomial coefficients are NCR times R factorial is NPR, which we'll use in the next chapter, which is permutation combination. Second is NCR is always going to be equal to n choose r, n minus r. Third one is the ratio of two consecutive binomial terms, okay? N choose r divided by n choose r minus 1 is n minus r plus 1 by r. The next one is what defines the Pascal's triangle, right? N choose r plus n choose r plus 1 is equal to n plus 1 choose r plus 1, right? Fourth one is that n choose r is nothing but n by r times n minus 1 choose r minus 1. And the last one is that n choose r by r plus 1 is equal to n plus 1 choose r plus 1 divided by n plus 1, okay? Alright, cool. So these are some properties of the binomial coefficients. Next thing is sum of the binomial coefficients, right? To get the sum of the binomial coefficients, what we do, we just look at the expansion of x plus 1 whole to the power n, and then we put x equal to 1, right? On doing that, you can see that the right hand side will give you just the sum of the binomial coefficients, and the value of that turns out to be 2 to the power n, right? Okay. Sum of the binomial coefficients at odd and even positions. So if I only look at r equal to 0, 2, 4, so on and so forth, or if I look at 1, 3, 5, so on and so forth, right? So both of them, the sum turns out to be 2 to the power n minus 1, right? Numerically greatest term is given by, for r you have to solve this inequality that r is going to be greater than equal to n plus 1 by 1 plus mod of x minus y minus 1, and it's less than equal to n plus 1 by 1 plus mod of x by y, okay? So this gives you the possible values of r, and among them you have to find which one gives you the numerically greatest term, okay? One application of binomial theorem that we use frequently is that if you look at the expansion of root a plus b whole to the power n, okay, anything of this form, it's going to be some integer I plus some fractional part f, right? Okay, and this fractional part is going to be between 0 and 1, and then from here you can say that 1 plus f times f is nothing but k to the power n, where k is nothing but a minus b square, okay, right? And root a minus b is less than 1. Similarly, if n is an even integer, then you get that 1 plus f times 1 minus f is nothing but k to the power n, okay? Alright, cool. So some properties of binomial coefficients, we saw the first one, it's nothing but the sum of the binomial coefficients. Second is if I alternate the sign, then it turns out to be nothing but 0, right? Because for the second one, you can just look at x plus 1 whole to the power n, and then you put x equal to minus 1, right? Okay. Third one is n choose 0, n choose 2, so on and so forth. We just saw that even positions and odd positions, it's nothing but 2 to the power n minus 1, okay? Coming to multinomial theorem, okay, multinomial theorem is when binomial we only had two terms, right, x plus a or x plus y, something like that. But if you have more than two terms, right, if you have x1 plus x2 all the way till xk whole to the power n, then that turns out to be summation over all k tuples r1 till rk which add up to n factorial by r1 factorial, r2 factorial all the way till rk factorial times the powers, okay, respective x1 to the power r1, x to the power r2 and so on and so forth all the way till xk to the power rk, alright. Now you can also extend the binomial theorem for negative and fractional indices. So that just looks like 1 plus nx plus n into n minus 1 by 2 factorial x squared, so on and so forth, which gives you an infinite sum, okay. So this is the binomial theorem for a negative or fractional indexes, okay. Next chapter, permutation combination. Permutation is a number of ways of selecting and arranging r objects out of n objects, right. So remember, whenever we talk about permutation, it's always selection plus arrangement. Combination is just selection, okay. So MPN, okay, suppose out of m objects, you are choosing n objects, then the number of ways in which you can do that is given by m factorial by m minus n factorial. Combination is a number of ways of just selecting n objects, right? So that's given by m factorial by n factorial times m minus n factorial, okay? Alright. If you assume that you have two different tasks, okay, this is counting principles. If you have a task x that can be done in m ways and a task y that can be done in n ways, then both the tasks can be done in m times n ways, okay? Right, they're independent tasks, so they can be done in m times n ways, okay. Similarly, if I have, so this is basically AND logic, right? You have this and that, okay, you want to do both the tasks. Similarly, if I ask you what is the number of ways in which one of these can be done, so if it's an OR logic, then it's always going to be sum, okay. So if I ask you the number of ways in which either x or y can be done, then it's going to be m plus n ways, okay, right. The number of ways of arranging n objects is n factorial, that's nothing but the product of 1 all the way till n, okay, cool. Now some simple properties, n choose n is always equal to 1, n choose n minus 1 is equal to n, because we know that n choose k is equal to n choose n minus k. We can also say that n choose 1, so this value is nothing but n choose 1, right. N choose r is nothing but n choose n minus 1, we already know that. The last one is npr is nothing but n choose r times r factorial, right. Now, if we talk about sampling with replacement, choosing items when they can be returned to the set after selection, right? So, with replacement means you choose something, you note what you have chosen, you record your observation, and then you put it back to the lot, and there's a chance you can choose that again, okay? That's the idea of sampling with replacement. Then the number of ways in which you can choose them is n to the power r, right? Because at every step you have all the n objects available to you, right? Sampling without replacement, if you are choosing r objects when they are not returned, then it's nothing but npr, right? Okay? Alright. Now, number of ways of arranging n different objects around a circular table is always n minus 1 factorial. If the circle can be turned over, right, if you can flip over the circle, then there will be half of it, right, so it will become n minus 1 factorial by 2. Grouping, if m objects out of n objects are to be grouped together, then the number of arrangements is n minus m plus 1 factorial times m factorial, okay, right. The coefficient of x to the power r, y to the power n minus r in this is nothing but n choose r, which is nothing but the application of binomial theorem, okay, cool. Next thing is balls and bins. The number of ways of putting r identical balls into n bins is nothing but n plus r minus 1 choose r, which is nothing but n plus r minus 1 choose n minus 1. Derangement, from here you have another idea, finding the number of solutions. So remember, the number of non-negative integer solutions is always n plus k minus 1 choose k minus 1, and number of positive solutions is going to be n minus 1 choose k minus 1, right, okay. Derangement is the number of ways of arranging n objects such that no object goes back to its original position, and that's given by dn is n factorial times 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial all the way till minus 1 to the power n by times 1 by n factorial, okay, cool. Now, if we talk about selection of one or more objects, then the number of ways in which at least one object can be chosen is what? You can choose any number of objects greater than 0, so it will be n choose 1 plus n choose 2 all the way till n choose n, which is nothing but 2 to the power n minus 1, right? The number of ways in which at least one object may be selected out of p-alike objects of one type, q-alike objects of one type, and so on and so forth is going to be p plus 1 times q plus 1 times r plus 1 minus 1, and you can extend it to any generalization, okay, of n types, okay, cool. Okay, in case you have three categories where they're of the same type and the last remaining n minus p plus q plus r objects are different, then the answer turns out to be this entire thing times 2 to the power n minus p plus q plus r minus 1, okay, cool. Alright, let's look at the next chapter, which is quadratic equations, okay. So what is a quadratic equation? It's basically a polynomial whose degree is 2. What is degree? Degree is the highest power of x in the entire expression, right? So a polynomial of degree 2 is known as a quadratic, and it looks something like ax square plus bx plus c, where a, b, c are real numbers and a, which is our leading coefficient, is non-zero, right? So a is the leading coefficient, the absolute term or the constant term is c, right? Standard form of a polynomial looks something like this, right? a0 plus a1x plus a2x square all the way till a n x power n, given that a n is non-zero, right? But for a quadratic, we work with ax square plus bx plus c equal to 0, okay? What are roots of a polynomial? Roots of a polynomial or roots of a quadratic are the values where the function or the polynomial vanishes, right? So if f of alpha is equal to 0 for some alpha, we say that alpha is a root of this, right? Of this polynomial, okay? Now, some of the roots, so every quadratic needs to have two roots, right? It's a degree 2 polynomial, so it will have two roots. So the sum of the roots is alpha plus beta, which is minus b by a, and the product of the roots is equal to c by a. And if you want to explicitly find the roots, you can use that using the Sridharacharya's formula, right? That the roots are minus b plus or minus square root of b square minus 4ac divided by 2a, right? Alright. Now, this quantity b square minus 4ac is very special to us, and we call it the discriminant. Why? Because it tells us the nature of the roots, right? So if discriminant is strictly positive, then you get real and distinct roots. If d is equal to 0, you get real and equal roots, and if d is less than 0, you get complex roots, right? Okay. Now, if you look at the function of a quadratic, if you look at it as y equal to ax square plus bx plus c, it's nothing but a parabola, right? Which is a later chapter, but it looks like a parabola whose vertex is minus b by a, comma minus d by 2a, right? Sorry, minus b by 2a and minus d by 4a, right? Where d is the discriminant, okay? So if a is greater than 0, it's an upward facing parabola. It will look something like this, where this is the vertex, right? Similarly, if a is less than 0, it's a downward facing parabola, right? Where this is the vertex, okay? Cool. And the next thing, the point where the parabola intersects the x-axis is, sorry, the point where it intersects the y-axis, okay. So next thing is intersection with the y-axis. The point where it intersects the y-axis is when you put the value of x as 0, right? So it turns out to be 0 comma c. Now if a is greater than 0, then f takes all values greater than equal to the y value of this vertex, right? Yeah, so it will take all values greater than equal to this, right? So it starts from minus d by 4a all the way till infinity. And if it's negative, then this is the maximum value of this, right? So this is the minimum value of this, and this is the maximum value of this, right? So it will take all values from minus infinity till minus d by 4a, right? So minimum or maximum value depending on the sign of a is this quantity, and the point where it takes the maxima or minima is minus b by 2a, right? The vertex of the parabola. Now if you have two quadratics, suppose we are comparing two quadratics, a1 x square plus a2 Got it. A1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. Then we say that these quadratics, both the roots will be common if the constants are proportional, right? If the coefficients are proportional, right? So you want a1 by a2 equal to b1 by b2 equal to c1 by c2. And for one common root, you want c1 a2 minus c2 a1 whole squared equal to a1 b2 minus a2 b1 times b1 c2 minus b2 c1, right? Okay. Now you can extend this idea of the relation between roots and coefficients to higher order polynomials as well, right? So if you have a degree 3 polynomial, then its sum of the roots is minus b by 2a, sorry, minus b by a, and the product of the roots taken 2 at a time, which is alpha beta plus beta gamma plus gamma alpha is going to be c by a, and the product of the roots alpha beta gamma is nothing but minus d by a, right? So these relations are known as Vieta's theorem, right? Okay, cool. Now range of the quadratic expression. Now if you restrict it to a domain, right, previously we were talking about all real values, right? If you restrict it to a domain, say x lies in between x1 and x2, then you can see that as long as a vertex does not lie inside this interval, then f lies in between minimum of f of x1, f of x2 and maximum of f of x1 and f of x2, right? But if the vertex, okay, if the point where the parabola has its vertex lies inside this range, then f lies in between the minimum of f1, f of x1 comma f of x2 comma the minimum value that it can take and the maximum of f of x1, f of x2 and minus b by 4a, right? Okay, cool. Location of the roots, okay, so if fx is ax square plus bx plus c where a is greater than 0, a, b, c are real numbers, then the condition for both the roots to be greater than the specified number x naught are that the discriminant should be greater than or equal to 0, right? Because if you are making a comparison of the root with some number, you need the roots to be real, right? Because we know inequalities only hold for real numbers, right? So you want the discriminant to be greater than or equal to 0, f of x naught has to be greater than 0 and minus b by 2a has to be greater than x naught, right? Okay, so in general for all these things, just plot the graph and see, okay? So in this case we have, suppose a is positive, right? So it looks something like this. You want both the roots to be greater than the specified number x naught, right? Which means x naught is here, alpha and beta are here, right? So obviously minus b by 2a should be greater than x naught, f of x naught should be positive and the discriminant should be positive, right? Similarly, if you do it for both the roots less than the specified number x naught, then again x naught is going to be positive. Now minus b by 2a is going to be less than minus b by 2a is going to be less than x naught and the discriminant obviously has to be positive, right? Same for 3, okay. The condition for both the roots to lie on either side of this number is going to be that f of x naught has to be less than 0. Condition of both roots to lie in between x1 and x2 is that f of x1 is greater than 0, f of x2 is greater than 0 and the vertex minus b by 2a lies in between x1 and x2, right? So conditions for exactly one root of f of x equal to 0 to lie in this interval x1 comma x2 is that f of x1 times f of x2 should be less than 0, okay? Cool. Coming to the next chapter, which is complex numbers. Alright, so the next chapter is complex numbers, okay? So what is a complex number system? It's basically the set of all numbers that look like something of the form a plus iota b, where I is defined as square root of minus 1 and a and b are individually real numbers, right? Okay, so the real part of it, it's basically a, right? A is known as the real part, b is known as the imaginary part, right? So now given any complex number, we can define its conjugate, which is given by z bar equal to a minus ib, right? So basically we change the sign of the imaginary part. Now some properties of it, first of all, mod z square. Now mod z is defined for any complex number as square root of a square plus b square, right? Okay, basically the distance from the origin. So mod z square is nothing but z times z conjugate. The conjugate of sum of two complex numbers is the sum of their individual conjugates, right? Same goes for the product, right? So z1 times z2 whole conjugate is z1 conjugate times z2 conjugate, okay? Now operations with complex numbers, so addition is very straightforward. You add the real parts together and you add the imaginary parts together, right? Same goes for subtraction, okay? So you take the real parts together, you take the imaginary parts together, okay? Multiplication, you multiply term wise while remembering that since iota is equal to root over minus 1, iota square is just going to be minus 1, right? Okay, so that gives you AC minus BD plus AD plus BC iota, okay? Now for division, what we do is we multiply the conjugate of the denominator to the numerator and the denominator so that we get mod of this squared in the denominator, so c square plus d square, and this is nothing but the conjugate of the denominator, right? Square root of a complex number, if z square is equal to x plus 5y, then finding the square root of x plus 5y. So if we define it to be some plus or minus a plus iota b, then what we do is we square this thing, equate it with x plus iy, and then solve for the values of x and y from here, okay? Alright. Sorry, solve for the values of a and b from here because x and y are given to us, okay? Cool. Representation of complex numbers, there are three different forms that we'll use. The first one is the Cartesian form, which is the algebraic form, right? Just write it as z plus iota y. Polar form is you multiply it with the modulus of it and you write the remaining thing as cos theta plus I sin theta, okay? Euler's form is you just write cos theta plus I sin theta as e to the power iota theta, and we get z is equal to r e to the power I theta, okay? Now from here, this is known as the modulus of it, this theta is known as the argument of this complex number, right? Okay? Now some properties of this argument. So argument of z1 times z2 is nothing but argument of z1 plus argument plus z2 plus 2 m pi, okay, for some integer m. Same goes for z1 by z2, it's just a difference plus some 2 m pi. Argument of z square is basically 2z arg, which basically follows from first property. Argument of z equal to 0 implies that z is a positive real number. Argument of z equal to plus or minus pi by 2 implies that it's a purely imaginary number and z is not equal to 0, okay. Cool. Rotation theorem. So if you have a complex number z2 equal to z1 plus e power I theta, if z1 is rotated by theta around z0, then this is the formula for z2, okay. So if you're rotating z2 around some point z0 by theta, then the new complex number you get after rotation z2 is given by this formula, okay. Next is De Moivre's theorem. So cos theta plus I sin theta whole to the power n is nothing but cos n theta plus iota sin n theta, right? Okay. Similarly, if you go for cos theta 1 plus iota theta 1 plus cos theta times cos theta 2 plus iota sin theta 2, so on and so forth, then it's basically cos of the sum of all the arguments plus iota times the sum of all the arguments, right? Okay. Cool. Same goes for if you take a rational power, again you can do it like this, okay, you can just multiply it and you'll get cos of 2k pi plus p theta by q plus iota times sin 2k pi plus p theta divided by q, okay. Alright. Cube roots of unity, right? Cube roots of unity are basically solutions of the equation x cube equal to 1. The three solutions of this are given by 1 omega and omega square. The properties are the sum of these cube roots is equal to 0 and the product is equal to 1, right? Similarly, you can extend this idea to the nth roots of unity, right? If you solve x to the power n equal to 1, then the solutions you get of this are known as the nth root of unity and they are given by 1 e to the power 2 pi I by n, 4 pi I by n, so on and so forth, right? So essentially it's cos 2k pi by n, okay? This is the general nth root of unity, okay? So these roots are obviously in a geometric progression because you're multiplying by a constant argument and the sum of all these roots is obviously going to be equal to 0, right? Okay. Some geometric properties. So the distance between two complex numbers z1 and z2 is nothing but the absolute value of z1 minus z2, okay? Section formula for internal division, it's the same as what you do for coordinate numbers. So it's m2 z1 plus m1 z2 divided by m1 plus m2, and for external division the plus sign changes with minus sign, right? Amplitude of z equal to theta is the ray emanating from the origin inclined at theta to the x-axis, right? So it's basically this entire line which makes a constant argument theta with the positive x-axis, right? This is the ray, okay? If mod of z minus a equal to mod of z minus b, then this is nothing but the perpendicular bisector of the line joining a and b, okay? The equation of the line joining z1 and z2 is given by z equal to z1 plus some real parameter t times z1 minus z2, okay? The equation of the circle having center z0 and radius rho is given by the modulus of z minus z0 equal to rho, and if you want to expand it by writing this mod z square as the complex number times its conjugate, you'll get some z bar minus z0 bar z minus z0 z bar plus z0 bar z0 minus rho square equal to 0, okay? Fine? Cool. The fifth one, if mod of z minus z1 plus mod of z minus z2 is equal to some constant k which is greater than z1 minus z2, then the locus of this ellipse, the locus of this complex number z is an ellipse whose foci are these two complex numbers z1 and z2. Similarly, if the ratio of this is some constant, if z minus z1 divided by z minus z2 is some constant, then this is nothing but a circle, okay? Similarly, if this difference is a constant now which is less than mod of z1 minus z2, then the locus of z is a hyperbola whose foci are again z1 and z2, right? Okay. Alright, let's look at the next question. So suppose you have a function fx which is defined piecewise as minus 1 plus sine k1 pi x if x is rational and 1 plus cos k2 pi x if x is irrational, right? So first of all, one thing you can observe is I can call this part f1 of x, I can call this part f2 of x, right? And the range of these two parts individually are what? Minus 1 plus sine k1 pi x is going to range in between minus 2 and 0 inclusive, and this one is going to range in between 0 and 2 inclusive, right? Okay. Alright, now we know that the period of sine k1 pi x is going to be what? It's going to be nothing but 2 pi divided by k1 pi. So which is basically 2 by k1, right? Okay, let's just call it some t1. Okay, let's say this is the period of t1. Now, what is the definition of a periodic function? That you want f of x plus t1 to be equal to f of x, right? First of all, for this to be equal, if x is rational, then if t is irrational, then this overall value will just be f2 of x plus t1, right? But the only values that f1 and f2 can take in common are 0. But for this to be 0, we want this to be an integer multiple of pi by 2, right? Or even integer multiple of pi by 2, whatever. Anyways, that would basically imply that k2 has to be some rational number, right? So even if x plus t1 turns out to be equal to f2 of x plus t1, then we get that t1 has to be a rational number, right? If not, the other case is that f1 of x plus t1, because x plus t1 is still a rational number, you still consider the first piecewise function part, right? So this turns out to be f1 of x, right? Okay, but for this to happen, we know the other case also gives us that t1 has to be rational. Now, if t1 is rational, which is the period of the first part, then the period of the second part also has to be rational, because the overall period of this function is rational, right? Okay, so that would imply that 2 by k2 is also, which is if you call t2, you want 2 by k2 to be also rational, which implies that k1 and k2 both have to be rational, right? That is question 30. All right. Coming to the next one, find the value of the limit n going to infinity 2024 minus 1 plus nth root of blah 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 whatever. The key thing to understand here is that this is something of the form 1 to the power infinity, right? This overall limit is of the form 1 to the power infinity, and I can rewrite this as limit n going to infinity 1 plus nth root of 2025 minus 1 divided by 2024, right? Whole to the power n. And what is the limit of this? This is nothing but e to the power limit n going to infinity. What is this going to be? Nth root of, so basically 2025 whole to the power 1 by n minus 1 divided by n times 2024, right? Because this n comes to the denominator. So you get this, right? Sorry, 1 by this thing, so 1 by n. Okay, and now if I differentiate this, if I use L'Hopital to find this limit, I'll get n going to infinity. This will become minus 1 by n square times 2025 whole to the power 1 by n times log 2025 divided by 2024 times minus 1 by n square. So this part cancels out, this goes to 1. So ultimately what you're left with is e to the power 1 by 2024 log 2025, which is nothing but 2025 to the power 1 by 2024. So that is the final value of the limit, which is option A, right? That is question 31. Coming to question 32. Find the value of k such that fx is continuous at x equal to 0. So f of 0 is given. So for this to be continuous, we basically want limit x going to 0 sin x whole to the power 1 by x plus 1 by x whole to the power sin x. We want this to be equal to k, right? Now if you look at this limit, the first part is nothing but 0 to the power infinity, which obviously goes to 0. So this limit just turns out to be x going to 0, 1 by x whole to the power sin x, right? Now you can basically use L'Hopital to find this. So suppose log, if you call this limit k, we can say that ln of k should be limit x going to infinity sin x ln of 1 by x, right? Okay, cool. I can write this, fine. Okay, now this can be rewritten as x going to 0 ln of 1 by x by, let's write 1 by sin x, okay? Which when you differentiate is going to give you limit x going to 0. Log of something is 1 by this, so x times minus 1 by x square divided by minus 1 by sin square x times sin x derivative, which is cos x, right? Okay. Now see, this x and x will cancel out. You basically get limit cos will go to 1. So ultimately you have x going to 0. This becomes minus minus cancels out. So you have sin square x by x, right? Now sin x by x goes to 1. Sin x goes to 0. So this overall limit goes to 0, right? So what is the value of k? ln k is equal to 0. So k is basically equal to 1, right? So the value of k that we want is equal to 1, which is option C. Okay? Fine. So that is question 32. Coming to question 33, again a similar question. Let fx be a piecewise function defined as follows. Find the value of p such that fx is continuous at x equal to pi by 2. So again, we just want limit. So we want p to be equal to limit x going to pi by 2 now. Cot x minus cos x divided by the denominator. I can rewrite this as if I take 2 common, I'll get let's take a minus 1 also common. Let's go with pi by 2 minus x. If you take the 2 outside, you'll get 2 cube, which is 8, right? This cubed. Fine. Now from the numerator, if I take cot x common, I can rewrite this as cot x times 1 minus, what is this going to be? 1 by sin x, right? 1 by sin x. This is cos x by sin x. Sorry, times sin x, right? Yeah. Divided by 8 times pi by 2 minus x whole cube. Now, if I'm a little smart over here, I'll rewrite this as x going to pi by 2. Keep the 1 by 8 outside. Cot of this, let's just go to the next line. Take the 1 by 8 outside. Limit x going to pi by 2. Now the first component, cot x, can be written as tan of pi by 2 minus x. And let's take one of these pi by 2 minus x's and keep it with this, right? Times 1 minus sin x is, if I use this, 1 minus sin x is basically, sin x can be written as 1 minus cos, let's just focus on this part, okay? So basically I want to bring everything in terms of pi by 2 minus x, right? So this part is nothing but 1 minus cos of some cos h, right? Where h is nothing but pi by 2 minus x, okay? So this becomes 2 sine square h by 2, right? So the second part will basically turn into 2 sine square pi by 2 minus x by 2, so divided by 2, divided by pi by 2 minus x whole squared. Now this part goes to 1, the first part, right? Because it's basically some h going to 0, tan h by h, which goes to 1, we know that. For the second part, we want a divided by 2 square here, right? Sorry. So we want a pi 4 here, so multiplied by a 4, okay? And what will you get? This entire thing will go to 1, right? Sine square h by h square. This will go to 1. So ultimately, what are you left with? So you have 1 by 8 times 2 times 1 by 4, right? Which gives you 1 by 16, which is the final value of p, okay? So p just turns out to be 1 by 16, okay? So you can use L'Hopital if you want, but I'm pretty sure L'Hopital is just going to make all these terms even more complicated, okay? So remembering trigonometric limits actually helps in a couple of questions. Okay, kind of question 34, find the total number of points of non-differentiability of maximum of sin square x, cos square x, 3 by 4, okay? Now if you observe one thing carefully, all three of them are periodic functions, right? Constant function is obviously periodic with an undefined period, fine, but it is periodic, right? So is sin square, so is cos square. So if I draw the graph of this between 0 and pi, okay? If I draw the graph of this between 0 and pi, what will I get? So sin will look something like this, cos looks something like this, and you have 3 by 4 somewhere around here, right? Okay? So if I look at the max of this, what will I get? So even if you don't look at the max, let's just outline it, okay? This is the max over here, this is the max over here, then you get this, then you get this, then you get this, right? Okay? Fine? And this is the point where, so this is sine, right? So this is the point where you get pi, okay? Let's say pi is somewhere around here where it becomes 0. So inside this interval, what is the number of points of non-differentiability that you're getting? Every sharp bend, right? Which is 1, 2, 3, and 4. Now because it's a periodic function, the number of points of non-differentiability should be the same in every subinterval of length pi. So in 0 to pi, if you get 4 points, from pi to 2 pi, you'll again get 4. So from 0 to 10 pi, how many will you get? 10 times the number of points of non-differentiability that you're getting here, right? The answer is going to be nothing but 4 times 10, so 40, okay? Just simple, observing the graph, that's it. Okay. Coming to question 35. Let fx be a differentiable function such that fx times gx is differentiable at x equal to a, then which of the following is true? First thing you'll observe that everything revolves around the differentiability and continuity of gx, right? So I can write this derivative. It's a weird way of writing it, but this is basically the first principle, that fx times gx at x equal to a is what? It's going to be ga times f prime a, right? Plus, because we are talking about the continuity and differentiability of G, I can write the second part as Fa times limit x going to a, gx minus ga divided by x minus a. Now see, if, let's look at the option, gx must be differentiable at x equal to a. Is that true? No, right? Because if somehow f of a becomes equal to 0, we don't care what this limit is, right? The second quantity is going to become 0 as it is, okay? So gx doesn't have to be necessarily differentiable at x equal to a. If gx is discontinuous, yes. If gx is discontinuous, then this limit does not exist, right? Then fa has to be equal to 0 for this overall derivative to exist, which is given in the question, right? So option B is correct. Similarly, question C is f of a is non-zero, then G must be differentiable. Yes, right? Because if fa is non-zero, the second limit has to exist. And we know by definition, if the second limit exists, then the function is differentiable, right? Which means if f is non-zero, it has to be differentiable. Hence, B and C are both correct, and it's just option D. So it was a very conceptual question, just using the definition of the derivative at a point, right? So that's question 35. Coming to question 36, let fx be sine cube rx where r is a non-zero real number, then which of the following statements is true? If r is, so what do you need? It's all about decreasing and increasing nature of the function, right? So if fx is, for us, fx is given as sine cube rx, which will give me f prime x as times cos rx, and there'll be a 1 by r outside, okay? But we can ignore it. No, we actually need it, yeah. Because there is a condition on r as well, so 1 by r, right? Sorry, times r. Okay, this is what the derivative looks like. Okay, now look at the options. If r is greater than 0, first of all, there's rx here as well. So 3 sine square rx. So let's look at the corresponding intervals where rx lies, okay? Because here, this is the value, this is the interval where x takes its values, right? So rx is going to lie in the interval pi by 2 to pi in this first case. Second case, it's 0 to pi by 2. Third case, it's minus pi by mod r, comma 0. And, sorry, it's going to be r by 2, pi by 2 times r by mod r is basically the sine of r, right? So I can write it like this, comma 0. And the fourth one is going to be again minus pi times sine of r times pi by 2, right? Okay. So these are the intervals where rx takes its values, right? Now look at the first case. If r is positive, forget about sine square rx, right? Because it's always positive. So we only need to focus on rx and r. So if I look at the interval, and if I look at the graph of cos x, this is what we get, right? So this is minus pi by 2, 0, and this is pi by 2, right? And then here is pi. Okay? These are the values. So if cos rx, if rx lies in pi by 2 to pi, you can observe that cos is negative. So r positive, sine square positive, cos negative. So this overall derivative is going to be negative. So it can't be increasing. So option A is incorrect. Similarly, if I look at option 2, if r is positive, then function is decreasing on 0 to pi by 2. See, 0 to pi by 2, cos is positive, sine square is positive, r is positive. So it can't be decreasing, right? It has to be increasing. Okay. So option B is also incorrect. If r is negative, then r is decreasing on this interval. What is this interval going to be? R is negative, right? So sine of r is minus 1. So you're still working with pi by 2. So it will basically turn into 0 to pi by 2, right? Yes or no? Okay, because of the sign will switch. So 0 to pi by 2, cos is positive, sine square is positive, but r is negative, right? Which means this derivative is going to be negative. Hence, option C is correct, right? Okay. So just looking at the nature of the graph, that's it, all right? Coming to question 37, if fx is a decreasing function which attains positive values, then the set of values of k for which the major axis of this is along the x-axis is minus a to b, then find a plus b. What do we know for the major axis? This is the value of a square, right? This is the value of b square. So I want a square to be greater than b square, right? Only then will the major axis of the ellipse be along the x-axis, right? So what do we have here? We want f of k square plus 2k plus 5 to be greater than f of k plus 5. But because it's a decreasing function, this would imply that k square plus 2k plus 5 should be less than k plus 11, right? Okay. Why could we directly write this? Because we know that it only takes positive values, right? So if a square is greater than b, we know for sure that a is going to be greater than b, right? Okay. Or rather, I mean, you get the idea, right? I mean, a is greater than b implies a square greater than b square, right? Because they're both positive. Fine. So now if I transform sides, I'll get k square plus k minus 6 should be less than 0, which means k plus 3 times k minus 2 should be less than 0, which by Wavy curve we know implies that k should lie in between minus 3 to 2. So minus a is equal to minus 3, which means a is equal to 3, b is equal to 2. So a plus b is going to be just 5, right? Which is option C for us. Alright. Okay, simple idea of decreasing function and some basic property of ellipse, okay? And the question 38. The function fx equal to x6 minus 3x4 plus 3x square minus 5, then which of the following is correct, okay? Obviously, again, we need to look at the derivatives. So f prime x just turns out to be 6x to the power 5 minus 12x cube plus 6x, right? Which gives you 6x, if you take it common, it's going to be x4 minus 2x square plus 1, right? Which is nothing but 6x times, this is x square minus 1 whole squared, right? Which can be written as 6x, x minus 1 squared, x plus 1 whole squared, right? Now if I use Wavy curve on this, what will I get? The nature of this derivative is going to look something like this, right? You have minus 1, you have 0, you have plus 1. Even power, you bounce off odd power, you cross, okay? This is what you'll get, right? So fx is decreasing on minus 1 to infinity. Is that true? No, right? Because in between it is negative, right? F prime is negative. So option A is incorrect. Option B, fx is decreasing in minus infinity to 1. Minus infinity to 1, that's wrong, right? Because there's a positive interval. F prime x is strictly greater than 0 for all non-negative values of x. Is this true? For non-negative values of x, is it strictly positive? No, right? Because in this interval and this interval, it's going to be negative, right? This is f prime that we are talking about, which means none of these options are correct. Hence, the right answer is D. Okay? Alright. Coming to question 39. The number of distinct real roots of this function is equal to what? Surprisingly, we will not use any polynomial theory over here. What we'll use is, so we'll use some of it obviously, but we'll look at the derivative of this, right? So f prime x turns out to be 4x cube minus 12x square plus 24x plus 1, which implies f double prime x, if you look at that is going to be 12x square minus 24x plus 24, which is just 12x square minus 2x plus 2, which is 12 times x minus 1 whole squared plus 1, which is strictly positive always. So if f double prime is strictly positive, then what can I say about f prime x? F double prime basically does not have any roots, right? Which means this has 0 real roots. Now see, if f prime has 2 real roots, by Rolle's theorem we'll know that f double prime needs to have at least 1 real root in between those 2 roots, which means f prime cannot have, so this can have at most 1 root, right? Could be 0, could be 1, but definitely not more than 1, that is the thing, okay? So at most 1, which means if this has at most 1, this can have at most 2, right? So this has at most 2 real roots. Now if we look at the nature of the graph a little, you'll get that f of 0 is what? F of 0 is equal to minus 1. What is f of 1? F of 1 is going to be 1 minus 4 plus 12 plus 1 minus 1. Okay, let's just write it down. 1 minus 4 plus 12 plus 1 minus 1, right? This to cancel out. So you have 13 minus 4. Sorry, 9, right? Okay. And what is f of minus 1? F of minus 1 is going to be 1 minus plus 4 plus 12 minus 1 minus 1, right? That is just 10 plus so 15, right? Which means if you, it's a continuous function, right? So if I draw the graph of this function, I can see that at minus 1, it's negative, right? At 0, it is positive. And at 1, again, it's negative, right? Sorry, 1 second. At 0, it's negative. At the other 2 points, it's positive, right? So here it's positive, here it's negative, here it's positive, right? Which means we know obviously for a fact 1 second. So over here we got that it has at most 2 roots, right? So f of minus 1 is positive, f of 1 is also positive, f of 0 is negative, right? Right. And what is this function? It's a degree 4 function, and we know it can have at most 2 roots. And we are getting 2 roots for sure from here, right? One of them is in between minus 1 and 0. The other one is between 0 and 1, right? Which means this can have exactly 2 roots, right? We know for sure it can't be more than 2, right? And we're getting 2, so it has to be exactly equal to 2, right? Okay. That's a simple question of application of derivatives, all right? All right. Coming to the next question. So what we have here is the radius of a right circular cylinder increases at a constant rate. Its altitude is a linear function of the radius and increases 3 times as fast as the radius, okay? So let's write down this information. So the rate of increase of the radius is a constant, right? So let's call it some c, and it's given that the altitude, so the height is a linear function of the radius, right? So let's write it as some a r plus b, and it's given that the rate of increase of the increase is 3 times as fast as the radius, right? Which means dh by dt, which is a dr by dt, is equal to 3 times dr by dt, which directly gives me the value of a as 3. Also, it's given that when the radius is 1 centimeter, the altitude is 6 centimeter, right? So when the radius is 1, altitude is 6, so it's 3 plus b, which gives me the value of b as 3, right? Okay? Cool. So we know explicitly that h is nothing but 3 times r plus 1. That's one of the important things we can derive from here. Okay. Now it's given when the radius is 6 centimeters, the volume is increasing at a rate of 1 cubic centimeter per second, right? So what is the volume? Volume is nothing but pi r square h, right? Okay. So volume is pi r square h, right? So if I plug the values, we'll get that this is equal to pi times r square times 3 times r plus 1, right? That's 3 pi r square times r plus 1, right? Now the rate of change of volume is given when the radius is equal to 6 centimeters, right? So what is dv by dt from here? This is going to be 3 pi. The thing inside is r cube plus r square, right? So if I differentiate it, it's going to be the 3r square plus 2r dr by dt, right? This is what I'll get. Now it's given that when the radius is 6 centimeter, the volume is increasing at the rate of 1 cubic centimeter per second, right? So from here, this is 1. So I can find out what is dr by dt. So dr by dt just turns out to be 1 by 3 pi times 3r square plus 2r, right? R was 6, right? So that's 3 times 36 plus 12, right? Alright, this is what we can say, okay? That just turns out to be times 360, okay? So I think, 1 second, that turns out to be 120 times 3, so 360 pi. Yeah, right. Okay. Now the question is, when the radius is 36 centimeter, the volume is increasing at a rate of n cubic centimeter per second. What is the value of n equal to? So now the volume is, radius is 36. So just plug this here, right? So dv by dt, which is equal to n, is going to be 3 pi times, this is going to be, radius is 36, right? So that's 3 times 36 square plus 2 times 36 times dr by dt, which is 1 by 360 pi. Okay, so this, if I simplify, this is going to be 3 pi. If I take 36 common, it's going to be 72, sorry, 36 times 3 plus 2, right? So that is going to be how much? 8 plus 2, right? So 110 times 1 by 360 times pi. So pi and pi cancels out, 36, this gives you 10. This cancels out, so ultimately you have 33, right? So the value of n is nothing but 33. Okay, simple, maybe a little calculative, but the idea is simple, right? Just using derivative as a rate of change, okay? So that is question 40 for us. Coming to question 41. Find the value of this integral 1 to 100 box x by x, okay? So first of all, this can be split into, this can be directly written as, so we're integrating over 1 to 100, right? Now I can split this into subintervals of length 1, right? over each interval. So 1 to 2, then 2 to 3 and so on and so forth, right? So this can be written as summation k equal to 1 to 99, right? Integral k to k plus 1 box x by x dx, right? Now in between the interval k to k plus 1, I know for sure that box x is always going to be equal to k, right? This just turns out to be summation k equal to 1 to 99 integral, so k times integral of 1 by x dx, which is just log k plus 1 by log k, right? Okay, so it's basically k log k plus 1 by k, right? Now if I substitute this and find the final sum, it's going to be log of 2 by 1 whole to the power 1 times 3 by 2 whole squared plus 4 by 3 whole cube times all the way to the last sum is going to be 100 by 99 whole to the power 99, right? Okay. So observe that you have 1, 2 remaining, you have 1, 3 remaining, you have 1, 4 remaining, you have 1, 5 remaining in the denominator, right? And numerator everything cancels out. So ultimately you'll just get log of 100 to the power 99 divided by what is the denominator going to be? 1, 2, 3 all the way till 99, which is just 99 factorial, right? So this is the final answer. Log of 100 to the power 99 divided by 99 factorial, which is option A. Okay? Clear? Alright, moving on. Alright, let's get the next question. So the next question is, let I be this integral equal to minus pi by 2 to e to the power pi by 2 sine square log x plus sine log x square dx, okay? So I think a very natural substitution would be to put, say, t equal to log x, okay? Which would basically give you x equal to e to the power t, right? Alright, so if I look at the limits of the integral, so I will now just look like, if x is equal to e to the power minus pi by 2, t is going to be minus pi by 2, and at the upper limit it's going to be plus pi by 2, right? And inside the functions would look like sine squared log x is just sine squared t, right? So this will become sine squared t plus sine of log x square is 2 log x, right? So this will just become sine 2t. And if I look at dx, so dt is equal to 1 by x dx, which implies dx is x times dt. Now x is e to the power t, so e power t dt, right? So times e to the power t dt. Now what do we do from here? We can break this as two different integrals, minus pi by 2 to pi by 2. Sine square we can break it as 1 minus cos 2t divided by 2 e to the power t dt plus integral minus pi by 2 to pi by 2 sine 2t e to the power t dt, right? Okay. Now what's the next obvious step? We just integrate both of this using by parts, right? So if I integrate the first one, what will I get? Or we can further actually split this first integral, okay? So we can write this as integral minus pi by 2 to pi by 2 e to the power t dt divided by 2, so bring that half outside, minus integral minus pi by 2 to plus pi by 2 cos 2t dt, cos 2t e power t dt divide, there'll be a divided by 2, and plus integral minus pi by 2 to pi by 2 sine 2t e power t dt, right? Okay, fine. Now one shortcut, one way would be to again use by parts on each of these, right? But there is a smarter way in which we can approach this. So write this first part as half minus pi by 2 to pi by 2 e power t dt. The second part can be written as integral minus pi by 2 to pi by 2, say minus cos of 2t by t plus sine 2t e power t dt, right? Now what is the second form? It's nothing but fx plus f prime x. See, what is the derivative of this? Sine 2t, so minus sine, right? So minus minus becomes plus, so sine 2t times 2, so 2 and 2 cancels out, so you get sine 2t, right? So this is fx plus f prime x times e power x dx, something like that, right? So the second integral, first integral we obviously know it's going to be half e power t, right? So e power t between minus pi by 2 and pi by 2, plus the second integral is going to be just e power t times minus cos of 2t by 2 between minus pi by 2 and plus pi by 2, right? Which will give you what? Half e to the power pi by 2 minus e to the power minus pi by 2 plus the second part is going to be e power pi by 2 times cos of pi, right? So that's minus 1, so minus minus becomes plus, so this will become plus half. So you can take the 2 outside. Yeah. Second one is going to be minus of cos of minus pi, right? Cos of minus pi is again minus 1, so this will be e to the power minus pi by 2 again, right? So this basically gives you e to the power pi by 2 minus e to the power minus pi by 2, right? Which is option D for us, right? Okay. Right, so remember this, okay? So sometimes you might need to observe these tiny facts even if it's a definite integral question, okay? It makes your calculation way easier, alright? Okay. Right, so in this question we have p of t given to us, then find the value of this integral times p of minus t minus 1, right? So p of minus t minus 1 is going to be what? If I plug this, you'll get minus t minus 1. Next term is going to be minus t minus 1 minus 1, so minus 2, right? All the way till minus t minus 2025 divided by 2024 factorial, right? Which just turns out to be minus, because there are 2025 terms, if I take a minus outside, you'll get this times t plus 1 all the way till t plus 2025 divided by 2024 factorial, right? This is what we are going to get. Now, observe that if I just consider a new polynomial, let's call it g of t. G of t is just t plus 1 plus 2025. Then what is log of gt? The sum of these, right? Summation of t plus k, where k ranges from 1 to 2025, right? Okay. Now if I differentiate this, what will I get? That 1 by gt times g prime t is 1 by, so there will be a log here as well, sorry. This will be a log of t plus k. Right, you'll just get summation 1 by k, right? Yes or no? This is what we'll get, okay? So basically g prime t is equal to summation of 1 by t plus k times g of t, which is basically this product t equal to 1 till t equal to 2025, right? This is what we'll get. And we are basically trying to integrate this times some constant, right? So if I just integrate this, the integral of this, so integral of summation of 1 by tk, t plus k, times t plus 1 all the way till t of t plus 2025 dt should be integral of gt between 0 and 1, right? Because the limits are what? 0 and 1. So this is going to be g0 minus g1, sorry, g1 minus g0, right? Now what is the final value you're looking for? You're looking for the value of this integral times some constant. What is that constant? You want this minus 1 divided by 2024 factorial. Only then will this convert into p of t minus 1. So multiply both sides by that. So basically minus 1 by 2024 factorial times g1 minus g0 is precisely the value of the integral you're looking for, right? This will become 0 to 1 summation of 1 by t plus k times, once you multiply these constants with gt, you'll get p of minus t minus 1, right? So what is this value that you need to find? What is g of 1 going to be? G of 1 is 2 all the way till 2026, right? Which is 2026 factorial. Minus g0 is going to be just 1 all the way to 2025, so 2025 factorial. So if you take 2025 factorial common from this, you'll get minus of this by 2024 factorial times 2026 minus 1, so that's 2025, right? And if you cancel out the 2024 factorial, you'll get minus of 2025 whole squared, okay? Fine. So it should be 2025 squared, but there should be a minus which is missing here, so it should be option D, alright? Clear? Okay. Coming to the next question. Define f from 2 to 222 to R, where fx is max of n times 1 minus mod of x minus 2n plus 1, where n ranges from 1 to 10. then the area of this region where y lies in between 0 and fx, where x lies in 2 and 22 is what? Alright, so first of all, as usual for any question of area under the curve, we need to first plot this graph, right? That is the first step. Okay, so as you can see that there are multiple graphs over here, right? And what do these graphs look like? The first graph is basically 1 times 1 minus mod of x minus 3. Next one is going to be 2 times 1 minus mod of x minus 5, right? Then 3 times 1 minus mod of x minus 7, and so on and so forth, right? All the way till n equal to 10. So let's start off by trying to plot these graphs, because that's essentially what you need to do for every question of area under the curves, right? So let's go to the next page. So first graph is basically 1 times mod 1 minus mod of x minus 3. What is mod of x minus 3? Mod of x minus 3 looks like this, right? X minus 3 would look like what? Yeah. So how do you draw this? X minus 3 is at x equal to 3 it will be 0, at x equal to 0 it's minus 3, this, right? So if I take the mod of this, it will start from here, right? So you'll get something like this. Okay. So minus of this is going to be the opposite of this. This is what you'll get, right? This is minus of mod of x minus 3, right? And what are you doing? You're adding 1 to it, so it shifts upward by 1, right? So essentially, if I remove all this and just draw the final graph, it would look something like this, right? At 3, something like this. Now we need to figure out the points, right? What is this point? At x equal to? When is this going to be equal to 0? We want 1 minus mod x, so x minus 3 should be equal to 1, right? Which means x is either 4 or it's equal to 2, right? So 2 and 4, and at x equal to 3, it's precisely going to be 1, right? So this is x equal to 3. Similarly, if I do it for twice of 1 minus mod of x minus 5, right? What is this going to look like? 1 minus mod of x minus 5, again similar. It's going to be from, again at 4, it will pass through this point, right? And the other point will be at 6, right? At 6, it's again going to be 0. So 4 and 6, but you're multiplying it by 2, right? So this value basically becomes double, right? So I can just shift it upwards. So at x equal to 5, what will you get over here? This value is going to be 2, right? So essentially you can see that at every interval, max is going to be this, then it's going to be this, and so on and so forth, right? So by induction, we can say that this interval's length is 2, the height is going to be 1 for the first one, it's going to be 2 for the second one, and so on and so forth, right? So the overall area can be written as half. See, the height is varying, but the base is fixed, right? So the base is fixed for all these triangles, so that's 2, and the height ranges from 1 for the first one, so all the way till 10, right? So what will you get? The sum from 1 till 10, which is basically 55, right? Okay? Alright? So simple, right? So first, just again, the first two graphs, you can make an educated guess what it's going to look like for the rest of them, and you directly get the answer as 55, right? Okay? That's it. Coming to question 45. Suppose S is a set of all integrable functions on real numbers and R is a relation on the set S such that R is all pairs f comma g such that integral minus infinity to infinity f plus minus infinity to infinity g is greater than or equal to 0, where f and g belong to S, then this relation is what? First of all, observe that if we look at whether it's reflexive or not. If I put f comma f, it's basically twice this integral, right? Minus infinity to infinity fx dx, right? This doesn't have to be necessarily positive, right? We can always find a function such that this integral itself is negative. So twice that integral is also going to be negative, right? So it's definitely not reflexive, right? So it's not reflexive. Okay? Is it going to be symmetric? Yes, right? Because I can just interchange f and g. The sum is still going to be greater than or equal to 0, right? So it is going to be symmetric. Now the question is it transitive or not? So obviously A is incorrect. It's not symmetric, so C is incorrect. So, but we need to check for transitive, right? Because we don't know whether it's transitive or not. So it's symmetric. But transitive, observe that integral f plus integral g, suppose it's greater than or equal to 0, and integral g plus integral of h is greater than or equal to 0. We want from here that the integral of f plus the integral of h should be greater than or equal to 0. Can we make any predictions about this? So checking whether it's transitive, let's come up with a very simple counter example, okay? Suppose that integral of g is actually, it's positive, okay? Assume f to be equal to 0, identically equal to 0, right? And assume that integral of g is actually greater than or equal to 0, right? So now, if I look at g by 2, 1 second. Let's go with this. We want the sum to be greater than equal to 0, right? G plus h is also greater than equal to 0. All right. Yeah, let's go with this. Okay. So g is greater than equal to 0. Now consider h to be minus of g by 2. So this overall integral g plus h, which is the second statement, is basically integral of g by 2, which is again going to be greater than equal to 0. So 1 and 2 are satisfied, right, with this construction. But if I come to the third one, this quantity is 0, and I've assumed that integral of h is just minus of g by 2. But the integral of g by 2 is positive, right? Which means integral of minus g by 2 should be less than equal to 0. And as long as it's not equal to 0, this condition won't be satisfied, right? So it can't be transitive. Hence the answer has to be option D, okay? So it's only symmetric, right? Cool. That is question 45. Coming to question 46. Find the area between the curves 2x to the power 4 minus x squared, the x-axis, and the ordinates of the two minima of the curve, okay? So how do we do this? So we need to start off by plotting this, right? So if I look at 2x squared times x squared minus 1, what is the sign convention of this graph? So you'll have minus 1, 0 and 1, right? So this is what it looks like. So these are the intervals where it's negative, these are the intervals where it's positive, right? Now we need to find the points of minima of this function, right? So just differentiate it, you'll get 12x cubed minus 2x equal to 0. So x is equal to 0 or x is equal to, so you'll get 12x square. 1 second. Sorry, this will be 8, right? So either x is equal to 0 or you can say that x square is equal to 1 by 8, right? Sorry, equal to 1 by 4. Which means x is equal to plus or minus half, right? Okay. Now you can clearly observe that at minus half and plus half, the function is definitely negative, right? And 0, it's exactly equal to 0, right? So it's a point of local maxima. These are points of local minimas, right? So if I draw the actual curve, what is it going to look like? So this is precisely what it's going to look like, right? And you need to integrate it between these points of minima, right? Minus half to plus half, right? How do we do that? See, overall in this interval, the function is always negative, right? So what do we get? We want integral minus half to plus half, integral of 2x4 minus x square. Now obviously this is an even function, so this is twice the integral 0 to half 2x4 minus x square dx, which is just twice of 2x power 5 by 5 minus x cubed by 3 between 0 and half, okay? So that gives you 2 times 1 by 32 times 5 minus 8 times 1 by 24, right? And if you solve this ultimately, what will you get? 160, right? 160 and 24. What is the LCM of these two? 8 4s are 32, 8 3s are 24. So you want a 8, you want a 3, you want a 4, right? Sorry, you want a 3. So 32, 8, 4. यहाँ पे काट देना, ठीक है, कैलकुलेशन वाला पार्ट. This will be by 480. This is going to be 3, right? 3 2s are 6 minus, it's going to be 2420, right? Okay. So it should have been minus of this, right? Because it's below. So minus of this, okay? Whatever you get. Remember this, okay? You want x-axis minus the curve of below, right? So this will be minus of this. So that gives you minus 14. So 2 times 14 divided by 480, right? Which turns out to be 240, 7, 120, right? So the final answer is 7 by 120, okay? So that is option A. Cool? Coming to question 47. The solution of the differential equation dy by dx equal to y by 2y ln y plus 1 minus x is what? Okay. Right. So obviously we don't want this complicated thing in the denominator, right? So if I take the reciprocal of this, I'll get dx by dy is equal to 2y ln y plus 1 minus x divided by y, right? Which gives you dx by dy is equal to 2 ln y plus 1 by y minus x by y, right? So this looks precisely of the form of a linear differential equation, right? So this is nothing but dx by dy plus x by y, x times 1 by y rather, is equal to 2 ln y plus 1 by y, right? This is what you'll get. Okay. Now from here, what is the integrating factor? It should just be e to the power integral of 1 by y dy, which is just ln y, right? So this just turns out to be y, right? So the final solution is x times the integrating factor is equal to integral of the second function. So 2 ln y plus y, 2 ln y plus y plus 1 dy, right? And on integrating this, what will we get? So let's just integrate this, right? So you have 2 ln y plus 1, right? ये last वाला question 47 काट देना, ठीक है? So next question is find the solution of the differential equation dy by dx equal to y by 2y ln y plus y minus x, right? So obviously this looks in a complicated form, so I can rewrite this as dx by dy is equal to 2y ln y plus y minus x divided by y, which can be rewritten as dx by dy. If I bring this minus x by y to the left hand side, I'll get x times 1 by y plus is equal to 2 ln y plus 1. So this is my function p, right? So what is the integrating factor? It's a simple linear differential equation. So it's e to the power integral of 1 by y dy, which is e to the power log y, which is just y, right? So the final solution is going to be xy is equal to integral of y times 2 ln y plus 1 dy, which is integral of 2y ln y plus integral of y dy, right? Plus some constant, obviously. This turns out to be twice of, what is the integral of this? It turns out to be y square by 2 ln y minus y square by 4, right? It's a standard integral. We have done this in y parts, right? So y power 4 by 2 plus y square by 2 plus some constant, right? So this and this will cancel out, right? After multiplying with this 2. So this is going to be, y square by 4. Yeah. So this multiplying by 2 will cancel out with this. You'll be left with y square ln y plus some constant. This is a value of xy, right? So what is x going to be? X is nothing but y ln y plus c by y. So y ln y plus c by y, right? So that's option A. Okay. All the options of 2, but there should not be a 2, right? 1 second. Okay, this 2 shouldn't be present. It should just be y times ln y plus c by y, okay? So that's option A is the correct answer, okay? Coming to 48, for what values of k do the following system of equations possess a non-trivial solution over the set of rationals? All right. So for this, so if you want this to possess a non-trivial solution over the set of rationals, we just want the determinant of the coefficient should be equal to 0, right? So we want the determinant 1, k 3, k minus 2, 2, 3, minus 4 to be equal to 0. And what does this turn out to be? 1 times minus 4k minus plus 6 plus k times minus 4, or let's go with minus k times minus 12 minus plus 4 plus 3 times 9 minus 2k. This should be equal to 0. So if I simplify this, what will I get? You want minus 4k plus 6 minus k times minus 8, so plus 8k plus 27 minus 6k, right? To be equal to 0. So what do you get? So you get 10. So 8, so that's 2. This gives you 33. So k is nothing but 33 by 2, right? Okay, so that's option D for us. Okay. Right. This question is, let A and B be 2 cross 2 matrices, then which of the following is always true? This is a standard result. You should know that determinant of A plus B plus determinant of A minus B is twice determinant of A plus twice determinant of B. But if you want to prove it and you don't remember it, the simplest way is take 2 cross 2 matrices A, B, C, D, B equal to E, F, G, H. Look at the matrices A plus B, A minus B. Their determinants are easy to calculate, right? These are just 2 cross 2 matrices. Compute the left hand side, compute the right hand side, look at which possible variation satisfies it, okay? So it will turn out to be option B, okay? That is question 49. Coming to question 50, suppose A, B, C are non-zero vectors such that A cross B cross C, so this vector triple product is 1 by 3 mod B mod C times A vector. And theta is the acute angle between the vectors B and C, then sin theta is equal to what? Okay. First of all, we know that the vector triple product can be written as a linear combination of the two coplanar vectors, right? A and B. I mean, the two vectors inside the first vector product. So this can be written as, A dot C times B vector minus B dot C times A vector. And that is nothing but 1 by 3 mod B mod C A vector, right? Now send this to the other side, and send this to the other side. What is B dot C? It's nothing but mod B mod C cos theta. So I'll get that A dot C times B vector is, if I take the mod outside, mod B mod C, I'll get 1 by 3 plus cos theta times the A vector. Now what I can do is I can just take modulus on both the sides, right? So left hand side will just become mod A mod B mod C. That should be equal to mod A mod B mod C times cos theta plus 1 by 3. So this and this will cancel out because they're all non-zero vectors, right? So you basically get that cos theta is going to be equal to 2 by 3, right? Okay. So minus 2 by 3. Sorry, yeah, just plus 2 by 3, okay? ये काट देना last वाला. Okay. काट देना ये question last वाला, okay? Alright, so in question 50, we have ABC are non-zero vectors such that this A cross B cross C is equal to 1 by 3 mod B mod C times A, right? So we know we can write the vector triple product as AC B vector minus B dot C A vector, and that is 1 by 3 mod B mod C A vector, right? Now from here I can write that A dot C times B vector is going to be equal to mod B times mod C. B dot C is what? Mod B mod C cos theta, right? Where theta is the angle between B and C. So I send it to the other side. I can take mod B mod C common from both the terms. I'll be left with 1 by 3 plus cos theta times A vector, right? Now observe that by the definition of a cross product, no matter what the first cross product is, the resultant is something that's perpendicular to A, right? Yes or no? The resultant is something that's going to be perpendicular to C, right? The cross product of any two vectors is perpendicular to it, right? And that is equal to A vector, right? It's some constant, some scalar multiple of A vector, which means A and C individually have to be perpendicular to each other, which means this A dot C is going to be equal to 0, which implies that cos theta is going to be minus 1 by 3 because A, B, C are all non-zero vectors. And if this is true, then what is the value of sin theta? Sin theta just turns out to be root over 8 by 9, so that's 2 root 2 by 3, okay? Which is option A for us, right? So these are the 50 most important questions for IIT 2025 in maths. Hopefully, we went over all the key important topics that you need from all the different chapters. We looked at different variations that you can get from different chapters. And once you thoroughly go through these 50 questions, I'm very hopeful that you'll be able to attempt most of the questions that come in IIT, okay? It's going to be some different variant of this, most likely. Okay, as long as you understand the topic, as long as your application part is clear, you should not be facing a lot of problems, okay? Alright, let's look at the next chapter, which is functions. So, some standard definitions. A function is basically a relation from the first set to the second set, which satisfies this property that exactly every element of the first set can get mapped to exactly one element of the second set, right? So you can't have something like this. If you have, say, element 1 over here and you have, say, A, B over here, you can't have one getting mapped to A and B both, right? But for a relation you can have both the pairs 1 comma A and 1 comma B inside a relation. But for a function this is not allowed, right? Okay, cool. So for every x there exists a unique y in B such that y is equal to f of x, right? That's the definition of a function. Domain is set of all possible input values that you can give to fx, which is basically the first set, right? Codomain is a set of all possible outcomes specified for the function. Doesn't mean whether it's attaining the value or not. As long as it's specified, it falls inside the codomain, right? Range is the actual outputs that it's taking, okay? So the ones where it gets mapped to, that collection gives you the range of the function, okay? Now what is a 1-1 function? A function is said to be 1-1 in f of x x1 is equal to f of x2 if and only if x1 is equal to x2, which means you cannot have two different elements which are getting mapped to the same output, right? You can't have this. Then it's called 1, 1. Onto is if for every element in the second set there exists some element in the first set such that x gets mapped to y, then it's known as a onto function or a surjective function, right? A function that's both 1, 1 and onto is known as a bijective function. Inverse function. So for a function that is bijective, you can also look at the inverse of that function, which is basically reversing all the arrows, right? So if you had 1 getting mapped to a, now you'll say that a gets mapped to 1, right? So this is basically what the inverse of this function is going to look like, okay? Composition of functions, again, if you take two different functions, you can just compose them, right? Say you have one function from a to b, say f, and you have another function from b to c, right? Say g. So every element here, whatever it gets mapped to over here, you take it further to the next one, right? So we'll say that under g of f of, say, a, b, c, then I'll say that g of f of a is nothing but g of b, right? Because f of a is equal to b, and that is nothing but c, right? So this f, g of f is what the composition of these two functions is, okay? Now, different types of functions, we already saw what 1, 1 onto bijective functions are. You have something that's known as an even function, right? So these are categorization based on the graph of the function or the values that it takes, okay? So if f of minus x is equal to f of x for every x, then it's called a even function, right? So it's symmetric about the y-axis. Similarly, an odd function is if of f of minus x is equal to minus of f of x, that is, it's symmetric about the origin, then it's known as an odd function, right? Examples, even function is x square cos x, right? Odd functions, x cube sin x. These are all examples of odd and even functions, right? Periodic functions, if f of x plus t is equal to f of x for some t greater than 0, then t is called the period of this function, okay? And this function is known as a periodic function. We saw this for sin and cos. The period is 2 pi, right? Okay. Domain and range determination, analyze the restrictions, okay? For example, if you have something in the denominator, you need to make sure that for the function to be defined, the denominator cannot be equal to 0, right? Similarly, you have logarithm of something, the argument inside the log needs to be positive, square roots need to be greater than or equal to 0, and so on and so forth, right? So that's how you determine the domain and the range of the functions. Inverse functions, okay? It only exists for bijective functions. What do? You write y equal to fx and solve for x in terms of y, right? Whatever you get as a solution gives you f inverse, right? Composition, you want the range of the first function to be equal to the or a subset of the codomain of the second function, right? Sorry, the domain of the second function. Different other categorization based on their nature, right? So you could also have increasing and decreasing functions, right? If f of x1, if x1 is less than x2 and f of x1 is less than equal to f of x2, then we say that this function is it's an increasing function, right? And if there's a strict inequality here, then we'll call it a strictly increasing function. Similarly, it's said to be decreasing if x1 less than x2 implies f of x1 greater than equal to x2, right? So if this inequality reverses, you call it a decreasing function. Again, if you have a strict inequality, you'll call it a strictly decreasing function, okay? All right. Right, moving on. Next is some important formulas. I mean, composition g of f is nothing but g of f of x. Inverse, we know how to find it. Periodic, even function, odd function, we have already seen it. Number of 1, 1 functions. Okay, the number of 1, 1 functions, if the first set has size m and the second set has size n, then the number of 1, 1 functions is given by npm, right? Which is n factorial by n minus m factorial. Okay, that's the first one. Onto functions, if the first set has size m and the second set has size n, then the number of onto functions is given by this. Okay. Number of onto functions gives you, it's basically using the principle of inclusion and exclusion. It's minus 1 to the power k, n choose k times n minus k whole to the power m, right? That's the number of onto functions from a to b. Periodic functions, if fx has a period t, then 1 by fx and root t also have period t. If fx is periodic with period t, then the period of f of ax plus b is nothing but t divided by mod of a, right? Every constant function is always periodic, but it does not have a fundamental period, right? It's not defined, so it doesn't have a fundamental period. Inverse functions, we have already seen it. Okay, so the next chapter is inverse trigonometric functions. All right. So for inverse trigonometric functions, let's just look at the properties. Okay, it's a chapter where you just have to memorize the formula. So the first property is when you have a trigonometric function and you're composing it with its own inverse, right? Then what happens? So if you look at sine of sine inverse, you get that it's always going to be x as long as x lies in between minus 1 and 1. Obviously, that's the domain of these functions. Cos of cos inverse x is equal to x. Tan of tan inverse x is equal to x. Cot, sec, they all are just equal to x itself. Okay. The second property is what happens when you take t inverse of some trigonometric function. Okay. The opposite composition, right? So sine inverse of sin x is going to be minus 2n pi plus x if x lies in this domain, and it's going to be 2n plus 1 pi minus x if x lies in this domain, right? So depending on where your value of x lies, it takes two different values, right? Same goes for cos. It's going to be minus 2n pi plus x if x lies in this domain, and it's going to be 2n pi minus x if x lies there, okay?
tan inverse of tan x is going to be just minus n pi plus x if x lies in between n pi minus pi by 2 and n pi plus pi by 2, right? Similarly, cosec and sec inverse are similar to sine and cos, okay, respectively, right? Cot is similar to tan, right? So cot inverse cot x is going to be minus n pi plus x if x lies in between n pi and n plus 1 pi, alright? Property 3, what happens when you take some t inverse of some minus x, right? Okay, so if you take sine inverse of minus x, it's minus of sine inverse x. Tan is again, it's odd. Cosec is also odd. But cos inverse of minus x turns out to be pi minus cos inverse x. Same for sec and same for cot inverse, okay? So these three follow one pattern. Sine, tan and cosec, they follow another pattern, right? Now, the sum of the trigonometric functions. So sine inverse plus cos inverse x is always going to be pi by 2. Tan inverse plus cot inverse x is going to be pi by 2 for every x in real numbers. Cos inverse x plus sec inverse x is equal to pi by 2 for every mod x greater than equal to 1, alright? Cool. Reciprocal function, so if I look at cosec inverse of x, it's nothing but sine inverse of 1 by x, right? Similarly, sec inverse is cos inverse of 1 by x. Cot inverse is going to be tan inverse 1 by x if x is positive. It's going to be pi plus tan inverse 1 by x if x is negative, right? Okay, so that's it. These are all the formulas that you need to remember from this chapter. Alright, so the next chapter we'll look at is limits, okay? So what is the idea of a limit? Basically, whenever we write something like limit x going to a fx equal to L, it basically means the closer we take the value of x to a, the closer the value of fx is going to go to L, right? Okay? Alright. Now, you need to know there are two ways in which you can approach this, because see, the entire idea is the value of x is getting closer to a, right? Now, on the real line, if you plot a, x can get closer to a from both the directions, right? So if it approaches from the left, right, we get something that's known as a left-hand limit, which is limit x going to a minus, right? Because all the values of x over here are what? They're a minus some quantity h. Similarly, if we talk about approaching from the right, over here the values of x are all what? They're some a plus h, right? So that's the right-hand limit, which is limit x going to a plus fx, right? So for a limit to exist at a point, you want both these limits to be equal to L, right? Okay, only then we'll say that limit x going to a fx is equal to some L, right? The fundamental theorems, the sum rule, so the sum of, if you take the limit of the sum of two functions fx and gx, then the sum of the limit is nothing but the sum of the respective limits, right? Similarly, for the difference limit x going to a, f minus g is L minus m, where the individual limits are L and m respectively, right? Same goes for the product rule, right? So the product is, you'll get L times m. Quotient rule is going to be L by m, given that the limit of the second function, that function in the denominator, is not equal to 0, right? If you multiply by a constant, see, a constant function always has a limit, right? It's equal to the constant itself, right? So it's basically a special case of the product rule, right? So you multiply by some constant k, then limit x going to a, k fx is nothing but k times L, where the, or just k times limit of x going to a fx, right? Now in this you have some indeterminate forms, right? So the general rule is you just plug the value of x equal to a in whatever the function is, right? But sometimes what might happen is when you plug the value of x as a in your function, the values that you get might not be determinate values, right? So these are known as the indeterminate forms, especially 0 by 0, infinity by infinity, 0 times infinity, infinity minus infinity, infinity power 0, 0 power 0 and 1 to the power infinity, right? Okay, so these are all known as indeterminate forms, right? So these are the special cases where you have to think about how do we calculate the limit, right? So for that we have a certain rules. The first one is the factorization method, right? Look for it could be something like x minus a factor in the numerator and the denominator, because of which you're getting an indeterminate form, right? So if it's because of that, you basically factorize it, cancel these things out. For example, here, the numerator and the denominator both become 0 when x equal to 1, because x minus 1 is a factor of both of these, right? So cancel it out and then evaluate the limit, which turns out to be minus 1 by 3, right? Rationalization method, again, you rationalize the numerator and the denominator and then you evaluate the limit, right? Using standard limits, there are some standard limits. For example, limit x going to 0. We know that sin 0 is 0, x is also 0. But limit x going to 0, sin x by x is equal to 1. Same for tan. Limit x going to 0, a to the power x minus x is nothing but log a, right? Okay. So these are some ways you can calculate the limits of indeterminate forms, right? Okay, what happens when x approaches infinity? These were all cases when x approached a finite number, right? Could be 0, could be some a and so on and so forth, right? But what do you do when x approaches infinity, right? So in general, what you do is you cancel out the highest power of x in the numerator and the denominator, right? You do that and then you evaluate the limit, right? Sometimes you might also need to look at the Taylor series expansion of the functions, right? So a few ones that you need to remember are e to the power x, sin x and cos x, right? E power x has the Taylor series, which is 1 plus x by 1 factorial plus x square by 2 factorial, so on and so forth. Sin is basically the odd powers of x with an alternating sign in between. Cos is the even powers of x with an alternating sign in between, right? Squeeze theorem, okay? Squeeze theorem or the sandwich theorem is basically if you have a function g which is bounded by f and some other function h, right? And if the limit of these bounds, if f and h have the same limit equal to some L, then we can say for sure that g is also going to have the same limit which is equal to L, right? Okay. L'Hopital's rule, okay? So if you have some indeterminate form which is 0 by 0 or infinity by infinity, these two cases, then what you can do is you can say that the limit is nothing but the limit of the derivative of the numerator and the denominator, right? So you differentiate the numerator, you differentiate the denominator, and then you solve the limit. And L'Hopital is very important because most of the questions you get in your exam can be solved using L'Hopital's rule, okay? All right. Next, continuity and differentiability, which is basically building upon what we learned in limits. So what is the idea of continuity at a point? A function is said to be continuous at the point x equal to c if you need three conditions. You want f of c to be defined, right? You want the limit at this point to exist, and you want the limit to be exactly equal to the functional value. If these three conditions are satisfied, then we say that the function is continuous at this point. Now, continuity on an interval is basically extending this point to the entire interval, right? So if you have an interval a comma b and the function is continuous at every point in that interval, then we'll say that the function is also continuous over that entire interval, right? Differentiability at a point. A function is said to be differentiable at a point x equal to c if this limit exists, okay? You want limit h going to 0, f of c plus h minus fc divided by h to be to exist, and it needs to be finite. Only then you say that the function is differentiable at this point, and the value of the derivative at this point is nothing but equal to this limit, okay? And that's denoted by f prime c. Cool. Again, just like continuity, you can extend the idea of differentiability to an interval. You want it to be differentiable at every point inside that interval. Then we'll say that the function is differentiable over the entire interval, right? Okay. Then you have the idea of a left-hand derivative. Left-hand derivative is just looking at the left-hand limit. Right-hand derivative is looking at the right-hand limit, which you already saw when we were doing limits, right? Okay, cool. Some key points. Continuity, a function must be continuous at a point to be differentiable there, but continuity does not imply differentiability. Basically, differentiability implies continuity, but not the other way around. It could be continuous, but it might not be differentiable, okay? But for a function to be differentiable at a point, it needs to be continuous at that point, okay? Right. Removable types of discontinuities. There are three different types of discontinuities that we'll talk about. First one is removable, right? If the limit exists, but it's not equal to f of c, or if fc is undefined, right? In that case, if we just define the value of this fc to be equal to this limit, then we can remove the discontinuity, right? So this is known as a removable discontinuity. What is a jump continuity? Basically, the left-hand limit and the right-hand limit they're not the same, right? It could be a function that looks like this, okay? It goes till here and then it starts from here, right? So there's a jump in the function. So this is a jump discontinuity, or the limit could be infinite, right? If the limit approaches plus or minus infinity, then again the function is going to be discontinuous at that point, right? Okay. Now, there are different ways of differentiating. One of the rules is chain rule, right? So if you have a composite function, if you have f of g of x, then differentiating with respect to x is going to give you differentiate f, you keep g as a variable, right? You treat it as a variable, so you get f prime g of x times you differentiate the function that's inside, right? So it just becomes f prime g of x times g prime of x, okay? Okay. Implicit differentiation for equations like f of x comma y equal to 0, right? Suppose it's a bivariate function. It could be something like xy square plus x equal to 0. So for differentiating functions like this, what you do is you differentiate keeping y as a constant, okay? ये काट देना implicit वाला as a constant वाला part काट देना. So to differentiate functions like this, what we do is you treat y as a variable of x, right? So when you differentiate it, you'll get x 2y dy by dx, right? Plus y square plus 1 equal to 0, right? So this is what you'll get after differentiating this, right? This is the idea of implicit differentiation. Parametric differentiation, suppose you have x as a function of t, y as a function of t, then dy by dx is nothing but differentiating both of them individually with respect to t and then taking the ratios, okay? Alright. Logarithmic differentiation for complex products quotients, you take log and then we differentiate it, right? For example, if you have something like, say, x minus 1, x minus 2, all the way till x minus n, right? If I want to differentiate this function, what I can do is I can take log of this, which will give me summation of log of x minus I. Now when I differentiate this, I'll just get 1 by x minus I, and on the left hand side, I'll get, suppose I call this some function f, the log of f is equal to this, so I'll get 1 by f times df by dx equal to this, right? So what is the derivative? It's nothing but the function times this summation, okay? Clear? So that's the idea of taking logarithm. Higher order derivatives, just like we define the first derivative, if we differentiate f prime again, then we'll get f double prime x, which is the double derivative of it, right? And you can keep on extending it till some n as long as it's well defined, right? As long as it's differentiable, you can keep on differentiating it, okay? Some important formulas. So this is known as finding the derivative by its first principle, right? Because we know that's how the derivative is defined. So f prime x is nothing but limit h going to 0, f of x plus h minus fx divided by h, right? Some standard derivatives. Derivative of x to the power n is n x to the power n minus 1, sin is cos is minus sin, tan is x square x, e power x is just e power x, a to the power x, the derivative is a power x ln a. Derivative of log x is 1 by x. Derivative of sin inverse x is 1 by root over 1 minus x square, and derivative of cos inverse x is minus 1 by root over 1 minus x square, right? Derivative of tan inverse x is 1 by root over 1 plus x square. Product rule, we have seen this, right? If you have two functions f and g, then the derivative is going to be f prime g plus g prime f, right? Okay. Quotient rule is basically treating the second function as 1 by v, right? Just treat 1 by v as the second function here and then use the product rule. It turns out to be second function times the derivative of first minus first function times the derivative of the second divided by the denominator squared, okay? We've already seen chain rule, implicit, parametric and logarithmic differentiation previously, okay? Cool. Now coming to application of derivatives, okay? How do we use this idea of derivatives in our questions? So in general, the geometric interpretation is whenever you find the derivative of a function at a point, the value that you get is nothing but the slope of the tangent to the function at that point, right? Okay, cool. So the angle that this tangent will make is nothing but tan inverse the value of the derivative, okay? Cool. So from here, you can also find out the slope of the normal, right? Because we know that the tangent and the normal are always perpendicular to each other. Hence the product of the slope should be equal to minus 1, right? So if I can find the derivative, I can find the slope of the tangent. From there, I can just write minus 1 by the derivative is going to be equal to the slope of the normal, which is minus dx by dy, right? Okay, cool. Equation of the tangent at a point, once we find the derivative, we can use the standard point slope form to find the equation of the tangent at a point. Same goes for normal, right? Okay. If the tangent is parallel to the x-axis, then obviously theta is going to be equal to 0, hence the derivative has to be 0. If it's parallel to the y-axis, then dx by dy is equal to 0. That is a normal, it should be, so when you find the slope of the normal, that should be equal to 0, right? Okay. If the tangent makes equal angles with the axis, then it's basically 45 degrees, so the derivative should turn out to be plus minus 1. Okay. A function is said to be increasing, okay? So this is the idea of monotonicity of a function using the derivative, okay? So a function is increasing at a point if the derivative is basically, so this is the definition, right? So we want f prime to be greater than or equal to 0, okay? This is the definition of strictly increasing. So we have already seen this. So, yeah, cool. So if double prime x is greater than 0, the graph is concave upwards or convex at the point. If f double prime x is less than 0, then the graph is concave downwards, right? Okay. Now first derivative test, if f prime changes from positive to negative, then x is a point of local maxima for the function, okay? Similarly, if it changes its sign from negative to positive, then x is a local minima. Similarly, basically what do? You take f prime, equate it with 0, you find the critical points and then you check the double derivatives, right? So if f double prime x is positive, then it's a point of local minima. If f double prime x is less than 0, it's a point of local maxima for the function, right? LMVT or the Lagrange's mean value theorem, a function is continuous and differentiable. Then you'll always find a point C in this interval such that f prime C is equal to fb minus fa divided by b minus a. Basically, if you draw a graph, what is this right hand side? It's basically the slope of the line joining the endpoints, right? So LMVT is telling you that you'll find some point in this interval where the slope of the tangent is equal to this line, okay? Or basically this tangent becomes parallel to the line joining these endpoints, right? That is what LMVT tells you. Rolle's theorem is a special case of LMVT. So if f is continuous, f is differentiable and fa is equal to fb, then there exists a point where f prime c is equal to 0, which makes sense, right? Because if fa is equal to fb, the right hand side becomes equal to 0. So Rolle's is basically a special case of Lagrange's mean value theorem, right? Okay. Now this is a generalization, remember this. If you have a function f such that f prime a, f double prime a all the way till the n minus 1th derivative of a is equal to 0, but the nth derivative at this point is non-zero. Then if n is negative and the nth derivative is positive, then you can say that f has a local minima at this point. Similarly, if n is even and this is negative, then you can say that it has a local maxima at a. If n is odd, then this is not a point of local extremum, okay, for the function. Cool? So these are the three cases, remember this, okay? Next chapter is integration again. It's a chapter where you just have to memorize formulas, okay? So what is the idea of integral? So if you have two functions small f and capital F such that capital F prime is equal to small f, then the function capital F is known as the primitive or the antiderivative, right? Because it's a reverse process of differentiation. So it's called the primitive or the antiderivative or the integral of this function f, and it's written as integral of fx dx is capital F plus some constant, right? So you can see if you have this, this is true if and only if the derivative of f is equal to small f, right? Okay, cool. Now some standard integrals that you need to remember. Integral of ax plus b whole to the power n is equal to ax plus b whole to the power n plus 1 by a times n plus 1. Similarly, you can do it for 1 by ax plus b, e to the power ax plus b, a to the power mx plus n, so on and so forth, right? So there's no point in me reading out these formulas. So you can pause the screen and take a screenshot, okay? So the first set of formulas for indefinite integrals. This is the next set of formulas, right? So here you have all those reciprocal forms, right? So integral 1 by root over a square minus x square is sine inverse of x by a times 1 by a, right? 1 by a sine inverse x by a. Similarly for 1 by a square plus x square, it's 1 by a tan inverse x by a. X times root over x square minus a square is 1 by a sec inverse of mod x by a, okay? Now, integration by substitution. So if you have an integral that looks like this, so it's a function of some other function times the derivative of the function that's inside, okay? In that case, what we can do is if we substitute phi of x equal to some t, right? If I put phi x equal to t, then I say that phi prime x dx is nothing but dt. So if I make the substitution, what will I end up with? I'll just end up with integral of f of t times this part becomes dt, right? So this integral reduces to this. This is the entire idea of substitution, okay? So some standard integrals from here, if you, so these are all substitutions where you're replacing ax plus b with t, right? So the next set of formulas, again, take a screenshot and remember these. Same for this one, okay? So this gives you an idea how to substitute and what to substitute, okay? So if we have something that looks like root over a square minus x square, this is a standard one, we already know this, right? So put x equal to a sine theta. Right, similarly, if it's of the form root over x square plus a square or root over x square plus a square, put x equal to a tan theta or cot theta, okay? Cool. So remember these. Integration by parts. What if you have the product of two functions, okay? See, finding the derivative of the product of two functions is very easy. But integration of the product of two functions is slightly difficult. So we have this idea that's known as integration by parts. So basically, if I have integral f and g, I call one of them the first function, the other one the second function, right? So this is the first function, okay? This is the first function times the integral of the second minus the integral of derivative of the first function times the integral of the second one, right? This is what you get, okay? This is what integration by parts tells you. Now the key question is, how do we decide which is the first function and which is the second function? So there is a rule for that, and it's known as the IIT rule, right? Where I stands for inverse trigonometric functions, L stands for logarithmic, A stands for algebraic, T for trigonometric, and E for exponential. So basically, write down IIT, look at the relative positions of the two functions according to this, right? So the one on the left is always going to be your first function, and the one which is on the right is always going to be your second function, right? That's how you decide which is the order in which you should take the functions, okay? So yeah, cool. Now definite integrals, okay? So what is definite integrals? Definite integral has a geometric idea which basically tells you that, right? ये पूरा काट देना, ठीक है? Definite integrals दोबारा start करते हैं. Now let's talk about definite integrals, okay? So whenever we write integral a to b fx dx, this has a nice geometric interpretation, which is this represents the algebraic area bounded by the curve fx between the points a and b and the x-axis, okay? And the way you find this definite integrals, see, if this has a, if you know that the indefinite integral of fx is capital F x plus some constant, then this just turns out to be fb minus fa. But not all functions have indefinite integrals, right? So for that, you have this formula to find the definite integral, right? This is known as finding the integral using first principle. Cool? Now the properties of definite integral. This variable is basically a dummy variable, right? So you can always change a variable. So a to b fx dx is nothing but a to b ft dt, right? Second is, if you switch the order of the limits, right? If you interchange them, you need a minus sign, right? So integral a to b is minus integral b to a, okay? Third is, you can always split this integral. So integral a to b is written as a to c fx plus c to b fx, all right? Fourth property is the King's property. So integral a to b fx dx is nothing but integral a to b a plus b minus x ds, okay? So you can always replace your variable x with a plus b minus x, right? Same, using this, you can write down integral 0 to 2a fx dx as 0 to a fx dx plus 0 to a 2a minus x dx, okay? Cool. Leibniz formula or Leibniz theorem, it stands for, now see, in all these cases, our limits were all constant values, right? But what if our limits themselves are functions of x, right? So in that case, whatever you get after integrating is also going to be a function of x. So if I try to find the derivative of this, what you get is f of the upper limit times the derivative of the upper limit minus f of the lower limit times the derivative of the lower limit, right? So this formula is known as Leibniz rule. Cool. You also have this reduction formula. So this is basically a recursion, okay? So if you have an integral that looks like 0 to pi by 2 sine to the power nx, okay? Then you have a recursive formula which tells you that in is nothing but n minus 1 by n, in minus 2. Same for tan, same for sine to the power m and cos to the power m, okay? Now using this, you can find out the values, okay? So if I keep on doing this, right, next term is going to be what? N minus 1 by n. Next is going to be in minus 2, right? So in minus 2 is going to be n minus 3 by n minus 2. And this continues until you reach some standard integral that you can solve, right? For example, if you reach all the way till n minus 1, or let's say sine square or sine, then we can find this final thing, right? So if it's 0 or say 0 or 1, right? We can find this limit. So using that, we can find out the value of this integral, right? And that is what Wallis theorem tells us. So this integral turn out to be n minus 1 times n minus 3 all the way till 1 or 0 depending on the value of n, divided by n minus 2 all the way till 1 or 2 depending on the value of n, right? Okay. Same goes for the second integral, right? Sine to the power n times cos to the power m. Again, we can evaluate it, okay, in the same way. Some general inequalities for integrals. So unlike derivatives, if f is less than g, we can't say for sure that f prime is going to be less than equal to g prime. This is not true for derivatives. But for integrals, we can do this, right? So if you have a function f which is bounded between psi and phi, let's say, then the integral of this function is also going to be bounded between the integrals of these two functions, okay? Similarly, if fx is bounded between two values, then I can say for sure that the integral is going to be bounded by the length of the interval over which you are integrating times the lower limit, and the upper bound is going to be the length of the interval times the upper limit, right? Third property, mod of the integral is always less than equal to integral of the mod, right? Because we know for sure that this is a strictly positive function, right? So the mod of the integral is always going to be less than equal to integral of the mod. Fourth property is f is a non-negative function. If f is greater than equal to 0, then the integral is always going to be greater than equal to 0 as well, okay? Right. Now, the area bounded by the curve, the x-axis and the ordinates x and a and b is given by this. We already know this is the geometric interpretation of the definite integral. If f lies completely below the x-axis, then the area is basically mod of whatever you're getting, right? Now, if the curve crosses the x-axis at x equal to c, then the area can be written as mod of the first part, right? So if it's below the x-axis till c, then you take the mod of the first area, and the second area we know is going to be positive, right? So the overall area turns out to be this quantity. Now you can also find the integral of some standard conics for u using this idea of definite integrals. So the area of this ellipse is going to be pi cd. Parabola, the area bounded by the parabola and its lattice rectum is going to be 8 by 3 a square. And the area bounded by two different parabolas, y square equal to 4ax and x square equal to 4by, is always going to be 16ab divided by 3. Okay, so these are some special cases that you should remember. Right. Alright, so the next chapter we'll see is differential equations, okay? So what exactly is a differential equation? It's basically an equation which involves dependent and independent variables along with the derivatives, right? For example, if I look at this case, y and z are dependent variables which depend on x. So you have y, z and its corresponding derivatives, right? So this is what an ordinary differential equation looks like. Partial differential equation is a similar one, except now we will talk about partial derivatives, all right? Cool. So now for every differential equation, you have two things that are associated to it. The first one is the order, which is nothing but the order of the highest derivative present inside it. Degree is the power of the highest order derivative present inside the differential equation, okay? Types of solutions, there are three major types of solutions, though you're only concerned with the first two. What is a general solution? In case you have a constant involved in the final solution, you can't say explicitly what the final solution is, then it's known as a general solution. Particular solution is one where you know the values of the constants. So if I give you an initial condition saying that y is equal to 0 when x is equal to 1 or something like that, in that case we end up with something that's known as a particular solution, okay? Singular solution is one where you can't obtain the general solution and you basically say that it's bounded by a family of curves, right? So something like that is known as a singular solution, okay? Linear differential equations, the general form of a first order linear differential equation looks something like this, okay? So it's dy by dx, so it's obviously the highest order is 1 here, plus px times phi is equal to qx, okay? And its solution is given by y times the integrating factor equal to integral of q times the integrating factor, where integrating factor is nothing but e to the power the integral of px dx, okay? Right? Exact differential equation, the exact differential equation is one of the form mx by dx plus nx by dy equal to 0, where the derivative of this first function with respect to y is equal to the derivative of the second function with respect to x, and you can find the solution by integrating m with respect to x and integrating n with respect to y. Okay. Homogeneous differential equation, a differential equation of the form dy by dx equal to the ratios of two homogeneous functions is known as a homogeneous differential equation. What is a homogeneous function? If f of lambda x comma lambda y is equal to lambda power n f of x y, then it's known as a homogeneous function. In such cases, what we do is we substitute y equal to vx and then solve the final differential equation. Okay. Bernoulli's differential equation is slightly advanced version of the linear differential equation. It looks like dy by dx plus px times y equal to qx times y to the power n. And to solve this, what we do is we make the substitution v equal to y to the power 1 minus, and then it transforms to a linear differential equation, and then we can solve it, right? Okay, you can see differential equation has a lot of applications even in chemistry, where you can say that the concentration of a chemical in a container can be written as dy by dx, which is nothing but y, the rate of inflow, right? The rate of inflow minus yt divided by the volume of the container times the rate of the outflow. Okay. Okay. Matrices and determinants. So matrix is nothing but a rectangular array which contains a lot of numbers, right? So a representation of numbers in the form of rectangular array is known as a matrix. The order of a matrix is defined by the number of rows and the columns it contains, right? For example, so every matrix is going to look like some m cross n, where m is the number of rows, n is the number of columns, right? A row matrix is one which only contains one row. A column matrix is one which only contains one column, right? Rectangular matrix where n is not equal to m. If m is not equal to n, then we call it a rectangular matrix. And if m is equal to n, then we'll say that our matrix is a square matrix, right? Diagonal matrix, a matrix where only the diagonal elements are non-zero, right? For example, here the diagonal elements are the only ones that are non-zero. That is a diagonal matrix. A scalar matrix is one where the diagonal elements are equal, right? What is an identity element? It's a diagonal matrix where all the diagonal elements are equal to 1, right? That's known as an identity matrix. Non-zero, if at least one element is non-zero, then we say that it's a non-zero matrix. If all the elements are equal to 0, then we say that it's a zero matrix, right? Upper triangular matrix, if you take a matrix where all the elements above the principal triangle are not equal to 0 and everything below the principal diagonal is equal to 0, then it's known as a upper triangular matrix. And if you reverse this, if all the elements below the principal diagonal are non-zero, then we'll say that it's a lower triangular matrix, right? Trace of a matrix for a square matrix is nothing but the sum of the diagonal elements of it, right? For example, in this case, it's basically the sum of the elements along this diagonal. Determinant of a square matrix of order n is a scalar value which is denoted by, so for 2D, it's a 2, so for a 2 cross 2 matrix, it's basically looking like AD minus BC, right? Okay. Right, so the value of the determinant remains unchanged if the rows and columns are interchanged, right? So if you interchange them, okay, if rows and columns are both interchanged, then the value of the determinant doesn't change. But if you only interchange the rows, right, only if you change the rows, then you need to take the negative of the value of the determinant, right? Okay. So a determinant, if you have a determinant where one of the rows or the columns is equal to 0, then the final value of it is also going to be 0. Similarly, if two of the rows or columns are equal, then the final value of the determinant is equal to 0, right? Symmetric and skew symmetric matrix. So for every square matrix, we have this operation that's known as taking the transpose of it, right? So A transpose is basically interchanging all the rows and columns. So if A transpose is equal to A, then we'll say that it's a symmetric matrix. Similarly, if A transpose is equal to minus A, then we'll say that it's a skew symmetric matrix, right? Okay. Also remember, if you multiply any row or column by a scalar k, then the overall values of the determinant also gets multiplied by the same scalar k, right? Okay. Cramer's rule is basically a way of finding solutions of linear equations, okay? So in this case, we have 3 equations and 3 variables, right? So the solution is given by x equal to d1 by d, y equal to d2 by d, z equal to d3 by d, where d is this determinant, right? D is basically the determinant a1, a2, a3, b1, b2, b3, and c1, c2, c3. And d1 is, so corresponding to every variable, d1 is basically going to be replacing the first column with d1, d2, d3. For y, if you want to find d2, you'll replace the second column by d1, d2, d3. And for z, you'll replace the third column by d1, d2, d3, okay? Now the adjoint of a matrix is the transpose of its cofactor matrix, right? And the inverse of a non-singular square matrix. So what is a non-singular square matrix? If the determinant is non-zero, right? So the inverse of this matrix is given by A inverse equal to adjoint of A divided by the determinant of this matrix, right? Some properties. Transpose of the product is given by B transpose A transpose, right? So when you take the transpose outside, you'll interchange the order of these multiplication, okay? So K times A transpose is given by K A whole transpose is given by K times A transpose. A inverse we know exists only if the determinant of A is non-zero. AB whole inverse is nothing but B inverse A inverse. A transpose whole inverse is equal to A inverse whole transpose, okay? Properties of adjoint. So suppose A is a square matrix of order n, then A times adjoint of A is equal to adjoint of A times n, which is nothing but the determinant of A times the identity matrix, right? Similarly, adjoint of the identity matrix is equal to the identity matrix itself. Adjoint of A transpose is nothing but adjoint of A whole transpose, okay? And the product, if you take the adjoint of the product of two matrices, it's nothing but adjoint of B times the adjoint of A, okay? So remember, you change the order of the multiplication here as well. Inverse properties. We know how A inverse is defined as adjoint of A divided by the determinant of A. A inverse whole inverse is nothing but A itself. K times A whole inverse is going to be 1 by K times A inverse, right? So you're taking the inverse of the scalar as well. A transpose whole inverse is nothing but A inverse whole transpose, right? And AB inverse is nothing but B inverse A inverse, okay? So even here you change the order of the multiplication, right? Vectors. Vectors is something you have done in physics, so this should be a comfortable topic for you. So any vector in 3D space is given by A1 I cap plus A2 j cap plus A3 k cap, right? So these are the components along the x, y, and z axis respectively, and I, j, k are the unit vectors along the three axes, okay? Magnitude of a vector is given by sum of the squares of the components, and then you take the square root of it, right? So it's square root of A1 square plus A2 square plus A3 square. Addition and subtraction of vectors, you always do it component wise, which means the x components together, the y components together, and the z components together, right? Multiplication of a vector by a scalar, you multiply all the components by the scalar k. Direction cosines, so if you have a vector that looks like A1 I cap plus A2 j cap plus A3 k cap, then the direction cosines are basically the cosines of the angles that this vector makes along the three axes, right? So if it makes angle alpha along the x-axis, then cos alpha is A1 by magnitude of A. Similarly, you define cos beta and cos gamma. Section formula, if you have two vectors A and B and you're looking for the vector which divides this in the ratio m is to n internally, that is given by mb vector plus na vector divided by m plus n. If you're talking about external division, the sign changes, right? So you change the plus signs to the minus sign, right? Linear independence and dependence of vectors. So three vectors is supposed to be linearly dependent if you can find three scalars k1, k2, k3, not all zero, such that this linear combination is equal to 0. If you can't find any such scalars, then we'll say that the vectors are linearly independent, right? Product of vectors, there are two different ways you can multiply. Primarily, one is the dot product or the scalar product, and the other is the cross product or the vector product, right? Dot product is just multiply the components together and then look at the sum of it, right? Which is also given by magnitude of A times the magnitude of B times cosine of the angle between the two vectors, right? Cross product, again, it's going to be defined as, so the final result is a vector here, right? So it's A2 B3 minus A3 B2 I cap, A3 B1 minus A1 B3 J cap plus A1 B2 minus A2 B1 K cap, right? The magnitude of this cross product is nothing but magnitude of A times magnitude of B times sine of the angle in between them, right? So you can use either of these formulas to find the angle between the two vectors theta. Scalar triple product, A dot B cross C is nothing but the value of this determinant that you get. Vector triple product, A cross B cross C is nothing but A dot C B vector minus A dot B C vector, okay? Area of a parallelogram and a triangle. So suppose you take two vectors, then the area of the parallelogram formed by these two vectors is given by the magnitude of the cross product. But if you look at the triangle, it's going to be half the area of the parallelogram, which is half times the magnitude of the cross product, okay? Moment of force, you have done this in physics. The moment of force about a point R is nothing but R vector cross the F vector, right? 3D geometry. Again, it's a buildup of the vectors, okay? So if you take 2 points in 3 dimension, okay? So for 2D, we have 2 coordinates, right? X and Y. Now we'll have 3 coordinates, X, Y, and Z. So the distance between them is that component-wise difference, square it, add it, take the square root of it, right? Section formula, if you have 2 points, X1, Y1, Z1, and X2, Y2, Z2, then the ratio, and if they're dividing into the ratio m is to n, then the point which divides it in the ratio m is to n internally is given by mx2 plus nx1 by m plus n. Same for y, same for z. Again, for external division, just change the plus sign to the minus sign, okay? Direction cosines and direction ratios, again, just consider the corresponding vector ai cap plus bj cap plus ck cap, then find the corresponding direction cosines, right? Okay. Equation of a straight line, suppose you have 2 points A and B, look for the corresponding vectors, then the equation of the line joining A and B is given by A vector plus lambda B vector, right? In the Cartesian form, it's given by x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N, where x1, y1, z1 is a point where the line is passing through, and L, M, and N are the direction ratios of the corresponding line. Angle between two lines, again, treat them as vectors, take the dot product, you'll find the value of cos theta, right? So it's nothing but L1, L2 plus M1, M2 plus N1, N2, right? Shortest distance between 2 points is given by this formula D equal to B1 minus B2 dot D1 cross D2 divided by D1 cross D2, okay? Sphere, equation of a sphere with center h comma k comma l and radius r. It's similar to what we did for a circle, right? So it's x minus h whole square plus y minus k whole square plus z minus l whole square equal to r square, right? So again, this entire thing is just a summary. It's a very brief recap of all the formulas, all the subtopics involved in all the chapters. If you feel that there is one particular section where you're slightly weak, make sure you go back and watch the rescue series or whatever lectures you're following. Make sure you make that topic clear and try to do the 50 important questions parallelly. Look at what kind of questions come from all these chapters. Go through the solutions, understand which subtopic the questions came from. So all the best for your exam. See you at your dream college.